Hi students, do let me know in the chat box if I am really visible and audible to all of you or not. Everyone in the chat box, and also let me inform the other students who have been waiting for such a long time today. Guys, there was some technical glitch and it is still there, right? But I thought of not cancelling the class because as we have promised that today we will do the class. So that's why from 3 p.m. I had been sitting in the studio working on the issues, right? Sometimes there are some technical issues that take time, right? It takes a lot of time, right? So let me just inform the other students. Yes. Yes, everybody. So today all of your ma'am voice is echoing. Wait a minute. Why voice is echoing? It should not be selected. Now tell me, is it echoing? Now tell me. Now tell me, I have done some settings. Is it echoing again? Yes, everybody? Yes, everybody? Yes, guys, do let me know. Is it echoing again? Yes, everybody, do let me know. Everyone, yes, is it fine? Is it clear now? Oh, so today it has been really a very hectic day for me. I've been literally standing here from past like 3 to 7, what you call, from past 5 hours I have been standing here. Actually not 3 to 5, it's 2:30 p.m. I have been standing here, right? And I'm just working on with the team that what exactly is the issue, right? But I was like, okay, today I have to take the class, I'll take the class. And so sorry for keep you waiting. I never want to do that, right? It's because of some issues only. And today your chats will be visible on the phone, right? On this mobile, I'll see your chats, right? Because some part is not working. So that's why today this is going to be our interactive place, right? Okay. So everybody do let me know if we shall start the session, and let's go and understand so many things that we have for CBSE board. So I have already taken one generic session where I have told you regarding what are the topics that we are going to do in today's class. So yes, everybody, these are the most important, most repeated, and you will see 95% of the board exam from the topics that I'm going to teach you in today's class, right? So we'll start with the sequence that is mentioned in your NCERT. We'll start with solution, then electrochemistry, chemical kinetics, and we'll go with inorganic chemistry. In the end, we'll do organic chemistry. Okay, so everybody do let me know. Shall we start? Yes? Aesthetic, ma'am? Okay, that's the credit goes to our graphic designer, right? Okay, so let's start. Everybody, green hearts in the chat box, and do let me know. Right, can I see class 12 students attendance here? Can I see class 12 students attendance here? Spam it in the chat box, class 12. Yes, I want to see your energies, your josh in the chat box so that we can do this session with less time and more knowledge, more questions. Will complete different kind of categories of questions we'll do today. Right, everybody? Everybody, most important chapters, ma'am. Yes. See, from every single chapter, I'm going to do most important topics. I'm not going to skip any chapter in today's session. today's session, because see, I thought we'll start with 5 p.m. and it will finish by 11 p.m. But now as it has started at almost 8 p.m. we have started it. So guys, definitely it will take us 12 p.m. right? By 12 p.m. only we'll be able to complete it. Before that, there are very less chances, right? Okay, so everyone, I need your energies, I need your josh here, right? Okay, so let's start the session without wasting any time. Let's start with, before starting, let me inform you that MBSAT scholarship program that has been extended to 2nd November, right? Earlier it was 28th of October, today was supposed to be the last date, but now it has been extended. We are giving you a final chance for those students who have not given the MBSAT scholarship program. This is your last chance and this is completely online. So you can give the test. 15 questions of physics, 15 chemistry, 15 maths will be there, right? And good level of questions will be there, unique questions will be there, right? But very interesting one which will help you analyze yourself as well, right? So all the students here, why I am asking you to do this, because you can win like worth 2 crore of prizes. You can win 100% free Vedantu courses, that is 100% scholarship on the Vedantu courses will be there, one-on-one counseling, international trips, all these will be there for the students who get in between 2.5 lakh students, right? Okay, so everybody, let's start the class. The first topic that we are going to do today is Henry's law and Raoult's law. So let's understand Henry's law and Raoult's law. This is from solution chapter, that is your first chapter, right? From solution chapter, the questions that are asked, there are short questions, short topics from where the questions are asked. First is Henry's law, then there is Raoult's law, ideal, non-ideal solutions, colligative properties. These are the 4 topics from where the questions can be asked in your exam. Definitely not beyond this they will ask, right? So, first is usually a neglected topic, that is Henry's law, right? Now guys, what we have seen that whenever you have a solution of gas, right, that means you have this liquid, right, and gas particles here, right? This is a liquid, let's say here you have some gas particles, right? Now what will happen here in these kind of solutions, right? In these kind of solution, for example, let's talk about 2 kind of solution. First solution is, for example, you have water, you are adding sugar into it, right? Now there is no impact of pressure. Why? Because sugar is solid and solid is incompressible. You can't compress this pen. Similarly, sugar is incompressible. That is the reason with applying more pressure, there is no difference that it makes on a solution which has solid in liquid. But if you have a solution which is gas in liquid, in that kind of solution, you can imagine a bottle of Coke, right? You can imagine a bottle of Coke that we usually daily life we use it, right? A bottle of Coke, what you have carbon dioxide that is under a very high pressure, right, in that Coke, right? So that is the reason that carbon dioxide, why it is under high pressure, because pressure is directly proportional to the solubility, right? So if you apply more pressure, more solubility will be there. The gas will be more soluble in the water, right? The gas will be more soluble in the water. Now, when I say the gas is more soluble in the water, right, that means the solubility has increased. Now, the factor which we represent, the concentration term from where we can represent solubility is mole fraction. So, you can also write mole fraction here. So, directly we can say that pressure is directly proportional to mole fraction, right? And you can replace this proportionality sign with KH, that is your Henry's constant. So, P is the pressure, right, of the gas, right, and the chi that we represent, this is actually called chi, okay. right? That students usually say X, this is chi, okay? That is mole fraction of that gas, and this Kh is the Henry's constant, and this law is called as Henry's law. The partial pressure of gas in vapor phase is proportional to the mole fraction of the gas in the solution, right? Now, based on this law, a very important question that can be asked to you, that is P is equals to Kh into mole fraction. Now, what is the graph of a straight line? What is a straight line graph? That represents y is equals to mx plus c is the formula, or you can say is the straight line graph, right? Now here y is the y-axis, so if I take y-axis as P, that is partial pressure, and if I take x-axis as mole fraction, if you're on x-axis I take mole fraction, then the slope, that is m, that is this m, that will be equals to Henry's constant, right? So this slope is defining the Henry's constant, and slope is also equals to tan theta, that you should know, right? That slope is also equals to tan theta, and tan theta is nothing but it is perpendicular by base, okay? It is nothing but it is perpendicular by base, right? So that will be your answer. Based on this, they can ask you a graphical question. It is not usually asked. Simple questions are asked based on Henry's law, right? Now you should know that unit of Kh are same as pressure. Why? Because mole fraction is unitless, right? Different gas have different value of Kh, different value, like oxygen has different Kh, carbon dioxide has different Kh, right? Kh values of gas increases with the increase in the temperature. When you increase the temperature, the value of Kh is going to increase. So Kh depends upon the temperature, important point. Higher the value of Kh, lower will be, this is also a very important line. This is also a very important line, that Kh, directly you can learn, Kh is directly proportional to temperature. If you increase the temperature, Kh will increase, and it is inversely proportional to solubility, right? If, let's say, which one will have more Kh value? You have helium and you have oxygen. Now helium is inert gas, so it will be less soluble, right? Oxygen is not an inert gas, it will be more soluble. So solubility of O2 will be more. But Kh value is inversely proportional to that. That means Kh value of helium will be more as compared to oxygen. These are the kind of questions that you should know, right? This is how you apply this particular concept, right? Okay guys, tell me if that is clear to all of you or not, so that we can start with the next thing, that is Raoult's law. Yes everybody, tell me. Yes, everybody in the chat box. Everybody in the chat box, tell me, is that clear? Now we are going to talk about the second part of this second topic of today's lecture, that is Raoult's law. It's actually not a topic, I have taken Raoult's and Henry's law in one topic only, right? So second is Raoult's law, right? Raoult's law also tells you partial pressure relation with mole fraction, but it's a different relation, okay? So here we say that when you have liquid in liquid, in Henry's law we are talking about gas in liquid, we are talking about carbon dioxide in liquid, we are talking about oxygen in water, right? But Raoult's law is based on when we talk about liquid in liquid. Liquid in liquid. Henry's law is telling you gas in liquid. It is telling you gas in liquid. So now Raoult's law means that what you have, again the relation is between partial pressure of the gas with mole fraction of the gas. But here we say that partial pressure of the gas when it is in a mixture, right? Let's say you have, this is the pressure of the gas when it is alone. This is the pressure of the gas when it is alone, it is not in a mixture. When you mix these two liquids, right, the pressure of A in a mixture, that is called as partial pressure of A. Pressure of B in a mixture is called as partial pressure of B. What is P naught A, P naught B? When you talk about the pressure, when you don't have a mixture, when A is alone, B is alone, that is called as P naught A, P naught B. So he says that Raoult's law states that partial pressure of a gas is equals to the multiplication of vapor pressure in the pure state, that's why we have written P naught A, multiplied by mole fraction of that component, right? So at constant temperature, the partial vapor pressure of each component in solution is equals to product of vapor pressure of pure component when it is not in a mixture multiplied by its mole fraction, okay? That is being multiplied by the mole fraction. Similarly, guys, you can say PB is equals to P naught B mole fraction of B, right? Then you add all of them. So this will be PS is equals to PA plus PB. What is PA? PA is mole fraction of A into P naught A plus mole fraction of B into P naught B. Now, when you put the value, now we know that mole fraction of A plus mole fraction of B is equals to 1. When you substitute the mole fraction of B as this, you will substitute as 1 minus mole fraction of A, right? You will substitute the value of mole fraction of B in terms of mole fraction of A. You can also substitute the value of mole fraction of A in terms of mole fraction of B, right? That also you can do, right? You will get this as your answer, and this is going to be in terms of mole fraction of A, right? Similarly, you can get the answer in mole fraction of B as well, right? So that is going to be your overall formula of Raoult's law, right? The graph of Raoult's law says that if you have a vapor pressure and mole fraction here, right, when you have mole fraction of component 2 as 0, one component has mole fraction 0, then its vapor pressure is also going to be 0. When its mole fraction is, so that's why vapor pressure, partial vapor pressure is going to be 0 when the mole fraction of 2 is 0, right? When the mole fraction of 2 is 1, then this will be the, see beta, simple thing is if you have P2 is equals to mole fraction of 2, P naught 2. When I say this is equals to 0, this is also equals to 0. So when mole fraction of 2 is 0, then the vapor pressure P2 is going to be 0. That's why we have a point here, right? When I say this is going to be 1, then P2 is equals to P naught 2. Right? That's why we are saying that P2 is equals to P naught 2 here. And we connect this is going to be our graph because this is a linear graph. This is a straight line graph. Y is equals to mx. Right? That's why we have written a straight line here. Similarly, you will have when mole fraction of 1 is 0, then P1 is equals to 0. When mole fraction of 1 is equals to 1, then P1 is equals to P naught, that's why it is here, and you connect, this is going to be the graph, right? And when you add these two things, you will have a straight line here which defines the P total, which is P1 plus P2. And this is your graph of Raoult's law, right? This is the graph of Raoult's law. Now let's see what are the questions that they ask you based on this particular thing, right? Let's see some, yes. Now we want to maintain a fact note for chemistry also. That's sweet. Chalo, let's see this, everybody. Value of Henry's constant, that is Kh. Let's talk about that. Now this is asked in latest CBSE 2023 question that has been asked to you. Value of Henry's constant Kh, that increases with decrease in temperature, decreases with increase in temperature, increases with increase in pressure, temperature, or remains constant. So we know that it increases with increase in temperature. So we can say it is directly proportional. So C is going to be the correct answer. Now they have already asked a question based on temperature, based on solubility also they can ask you a question that I have already told you, right? Next kind of question that they ask is, let's see from the Raoult's law. Vapor pressure of chloroform of a component is given to you and dichloroethane at 25 degrees is this and this respectively, right? Vapor pressure of solution obtained by mixing this much of chloroform and this much of dichloromethane at the same temperature will be what? Okay. That means they are asking you PT, total pressure, that is PA plus PB, right? That is P naught A plus P plus mole fraction of A. This is P naught B mole fraction of B, right? So pressure of chloroform is called as P naught A, right? This is called as P naught B, right? Mole fraction you can calculate here. What is mole fraction? Mole fraction of A is equals to number of moles of A plus number of moles of A plus number of moles of B. And mole fraction of B is equals to 1 minus mole fraction of A. How do you calculate number of moles of A? By weight of A by molar mass of A. This is weight of A by molar mass of A plus weight of B by molar mass of B. And that's how you put all the values. Weight you know, molar mass, they have also given you the molar mass here, right? In CBSE, so they also give you the molar mass, right? They make things really easy for you, right? So in CBSE, if this question, usually this question will not be asked in a MCQ based format. This question will be asked in subjective way only, most probably, but they have MCQs also. So mostly in MCQs, they don't ask you like numerical based questions, right? So even for writing these steps, they will give you the marks, right? So here you have, this value is 25.5. This is divided by what? This is 119.5. This is 25.5. This is 119.5. This WB is given to be 40 and this is given to be 85. And that's how you will calculate all of them, do the calculations, right? Then once you have the mole fraction of A, mole fraction of A will be 1 minus mole fraction of A. Put all the values here and you will get your answer of P total, right? You calculate the number of moles, you calculate number of moles of other, you put in all the values here and you will have your answer here, right? All you need to do is you should be good in calculation, but for CBSE board exam, they also give you marks for steps, right? Even if you know the formula, this is for those students who are weak in calculation, I am telling you. CBSE also gives you marks for writing the formulas, right? If this question is of 2 marks or 3 marks, they will give you 1 mark for writing the formula here, for writing the values. When you write down everything that this is P naught A, this is P naught B, when you write everything in detail, and then you're like, I am not good in calculation, even then they can give you 2 marks out of 3 without doing any calculation. And some teachers might give you 2.5 as well, right? Okay, so that's the benefit. Let's talk about the next thing here. That is ideal, non-ideal solutions, right? So guys, ideal solution is the one which follows Raoult's law, right? The one which follows Raoult's law, right? That is the ideal solution. Interaction of AB, that means A and B, those two, one solute or two solute, you can say one solvent, one solute that you have added, two components, right? When A was, their interaction of AA and BB is same as AB. There is no difference. It's like when you are studying alone in your room and when you are studying with your friend, you have the same results, which is rarely possible, right? So that is an ideal solution, right? It means it can only occur when two components have almost similar properties. Either they are homologues of each other, like N-hexane, N-heptane, benzene, toluene, or it can be chlorobenzene, or this different substituent and bromobenzene, bromobenzene. Now these are also the ideal solution because there is only one difference, chloro and bromo, and that is also belonging to the same group. That is why they have the same properties. That's the reason they follow Raoult's law. That means we can say that PT is equals to P naught A mole fraction of A plus P naught B mole fraction of B, and in this case delta V mixing is 0, delta H mixing is 0. There is no difference in that, but delta S mixing entropy will always increase and delta G mixing will always decreasing. No matter it's ideal solution or non-ideal solution, this will always remain same. Entropy of the universe always increases, Gibbs free enthalpy will always decrease, right? Now when we talk about non-ideal solutions, that is also divided into two categories further. These two categories are positive deviation and negative deviation, right? Now I'll give you a simple concept to remember this in exam, right? So guys, just relate it to your daily life. When you have positive deviation, for example, when you are sitting alone in your room and you're doing studies, right, self-study you're doing, let's say you're getting less marks, and when you're studying with a friend who is already a topper, who knows everything, and he is also very like motivating you, encouraging you to, you know, learn more, right? Then you go to their house, you do group study, right? Because that your friend is quite intelligent, he is also giving you tips like these are important topics. So now you will have a positive deviation. That means your marks will increase. But it will only increase if you don't interact with each other, if you don't gossip with each other. That means if gossiping is less, only then your marks will increase. So positive deviation is only possible when the interactions are less, right? So AB interactions are weaker. When AA was sitting alone, BB was sitting alone, they were having more interactions as compared to AB interactions. That's why it's a positive deviation. The pressure, that is PT, is greater than P naught A mole fraction of A plus P naught B mole fraction of B. And here we are saying that in negative deviation, when you are like okay, I am not able to study, you go to your friend's house, right? You are doing group study and nobody is studying there, right? Everybody is chit-chatting, gossiping about this and that thing. That will lead to a negative deviation, right? You won't be able to study. You will have less marks. In the end, you will get less marks. So we can say that there will be negative deviation there, right? So what we can say, AB interactions, right, are stronger, right? In that case, PT is less than P naught A. The pressure is going to decrease here, P naught B, mole fraction of P, right? Now, this we talked about interactions, we talked about pressure, right? But in positive deviation, pressure increases and delta V mix and delta H mix is also positive, right? In negative deviation, pressure decreases, delta V mix and delta H mix is also negative here, right? Keep in mind that delta H for a non-ideal solution as well, delta S will always and always increase and delta G mixing will always and always decrease. This doesn't matter, it's ideal or non-ideal solution. Based on this, they can ask you an MCQ based question, they can ask you assertion reasoning question based on this part, right? Based on the differences, they can ask you MCQ based question, right? They can ask you, yes, they can ask you MCQ based question. No worries, Sonika, Rohit, Vijay, Sham, Ashwath, Negi, Divyanshi, right? Yes. Hi Divyanshi, welcome to the class. Sham, Pratiksh, Praktish, Piyush, very good. Pranav, yes everybody, tell me, is that getting clear in your head? Now, another question that they can ask you in MCQ. Now, I'm also telling you what type of question they can ask you from a certain topic. Now from this part, they can ask you MCQ based question most probably, right? From the examples, they can ask you a lot of questions, right? Let's firstly talk about the examples here. From the examples, how they will ask you the question, right? You should know about these examples here, right? If we talk about positive deviation, right? Simple concept there is that in positive deviation, interactions will decrease. Here, interactions will increase. Here you will always see that water, right, and chloroform, they will, water already had hydrogen bonding, its hydrogen bonding will decrease. Ethanol had hydrogen bonding, interactions will decrease after CCl4 addition. Methanol had hydrogen bonding, it will decrease. Methanol here had hydrogen bonding. Acetic acid was forming a dimer, but now on addition of a toluene, which is a non-polar or with less polarity, it will decrease. Ethanol was forming hydrogen bonding, but in addition with acetone, its hydrogen bonding will decrease. Again, methanol was forming hydrogen bonding, but with addition of water, it will decrease, right? Again, this is ethanol, which is forming hydrogen bonding, but in addition of cyclohexane, it will decrease. In case of negative deviation, you will see all the examples, the interactions will increase. Methyl acetate had no hydrogen bonding, but because chloroform is very polar in nature, so dipole-dipole interactions will increase, right? Here on addition of HCl, what will happen? Its interactions, when you talk about you have HCl, you have added water here, the hydrogen bonding is going to increase. With nitrogen also, it is going to show more hydrogen bonding here, right? Acetic acid and pyridine, they are going to show more interaction because of an acid and a base here. Phenol and aniline, both shows hydrogen bonding, but when they are together, the number of hydrogen bonds shown by aniline is more, that's why interactions will decrease. So I have also given you a quick reason why these examples are here and are here, and from these examples they can ask you an MCQ based question or a assertion reasoning question based on these examples, right? So let's talk about which one of the following is incorrect for ideal solution. A simple question for your MCQ preparation, which one of the following is incorrect for ideal solution? For ideal solution, this is correct, right? For ideal solution, this is delta G mixing. I never told you that that is equals to 0, right? See, if delta H is 0, delta U will also be equals to 0, right? And delta P is equals to P observed minus P calculated by Raoult's law, right? That is the change, that is also going to be equals to 0 because observed and calculated are going to have the same values, right? Delta G mixing is always less than 0 even for an ideal solution. That means D is going to be the correct answer here. That is the incorrect way of saying that this is true. Delta S is also not equals to 0 even for an ideal solution here, right? Next kind of question, that is assertion reasoning type of question that they can ask you, and assertion reasoning questions, guys, they specially ask you, right? So let's talk about that, everybody. Let's talk about the assertion reasoning questions that they can ask you. An ideal solution obeys Raoult's law, that is true. Always write true and false here, true. An ideal solution, vapor pressure of solute and solvent and the corresponding activities in solution are proportional to their mole fraction. The pressure of solute, solvent and the corresponding activities in a solution are proportional to their mole fraction. That is also true, right? So, but they are not giving any explanation. Ideal solution obeys Raoult's law, right? So, if you talk about, yes, if you talk about why the ideal solution obeys Raoult's law, why PA is equals to P naught A plus P naught A mole fraction of A plus P naught B plus mole fraction of B, because vapor pressure are directly proportional to the mole fraction. See, why PT is equals to P naught A mole fraction of A plus P naught B mole fraction of B, because in an ideal solution, PA is equals to P naught A mole fraction of A, and PB is equals to P naught B mole fraction of B. That is the reason we put the value PA and PB here and you get this value. That is why it is true, right? So both reason is the correct explanation of assertion as well. That's why this is the correct statement, right? Okay. Now let's see next category, next topic, that is the third topic of today, guys. The third topic of today, that is colligative property, and 100% I can guarantee question will be asked, right? One question is definitely will be from colligative property, right? One question, guys, definitely is going to be there from colligative property. So let's talk about that, right? Right, everybody? So let's talk about colligative property here, right? Colligative property. So properties of solution which do not depend upon the nature of solute but only depend upon the number of solute particles, right? Only upon the concentration of solute particles, that is called a colligative property, right? 4 colligative property we have, out of which one colligative property is definitely going to be in your exam, right? There can be one big question of 5 marks also they can ask you from this particular section, right? I am not saying an MCQ will be asked. MCQ may be asked, may not be, but here from this topic the chances are they can ask you a 5 marks question from here, right? So this topic is going to give you a lot of questions, so see this topic very carefully. 4 colligative property we have: vapor pressure, boiling point, freezing point, and osmotic pressure. One by one let's talk about that. So in all these cases we are adding non-volatile solute, a solute which is not forming any vapors, right? The solute that is not forming any vapors will always decrease the vapor pressure, because earlier the vapor pressure was high. When you add a solute which is not forming any vapor, that will lead to less vapor pressure. So vapor pressure is going to decrease. That is called lowering in vapor pressure. And when you divide that change in vapor pressure with the original vapor pressure, that is called as relative lowering in vapor pressure. That is P naught minus P is divided by P naught is more equals to mole fraction of solute. That means number of moles of solute by number of moles of solute. Solute you can say as N2. This is N1 plus N2. Right, you can also write it as N1 by N2 here. Sorry, N2 by N1, right? N2 by N1. Because solute particles are quite less as compared to solvent particles. You can also write it like this. You can also write it like this: W2 by M2. This is W1, this is M1, right? Where 2 we are representing as solute and 1 we are representing as solvent. This is the direct formula that we will apply, right? Second is elevation and boiling point, right? So understand one thing here. So whenever I say that boiling point, vapor pressure is always inversely proportional to boiling point. The question is, ma'am, why? Because can you tell me what do you mean by a boiling point? Any one of you who can tell me what do you mean by boiling point? Yes. Guys, boiling point exactly is when that temperature where vapor pressure of that particular solute is equals to the atmospheric pressure, right? So let's imagine it like this, right? For example, this is the atmospheric pressure, right? And this is your vapor pressure initially. You can say this is, let's say, P naught. And when you add a non-volatile solute, vapor pressure decreases. So initially this was the boiling point, because when vapor pressure equals to atmospheric pressure, that becomes the this becomes the boiling point. That means this much temperature you need to make pressure equals to atmospheric pressure. So this becomes your TB0, right? Now we are saying that when you add non-volatile solute, vapor pressure decreases, that we have discussed here, that vapor pressure will decrease. Now that means vapor pressure decreases. Let's say this is your new vapor pressure. Now what you will see, atmospheric pressure and P has this difference, this is TB. So now we can say that TB is greater than TB0. That's why there is elevation in boiling point has increased. And what is delta TB? Delta TB is TB minus TB0, right? And it is equals to Kb into molality. This M is called as molality. Molality, right? What is molality, everyone? Molality is nothing but it is number of moles of solute, that is W2 by M2, right, in 1 kilogram of solvent. That means divided by 1 kilogram. If you write this weight in grams, this will be multiplied by 1000. And that is molality. This is the formula that we are going to use for delta TB, that is elevation in boiling point, right? Correct, everybody? Yes. Is that clear? Is that clear, everyone? Next, let's see this graph here. A very important graph mentioned in your NCERT. So now if you see this graph here, this is between vapor pressure and temperature. We can see that solvent, this is the curve of solvent. Now we know that whenever you add a non-volatile solute, the overall vapor pressure is going to decrease. That's why this is this curve is less. That's why this curve has decrement, and this is your original curve, that is the solvent, right? Now what you will see here, this is 1 atmospheric, right? This is the point where it strikes the solvent, and that becomes your TB0. This is the point where solution strikes 1 atmospheric, and this becomes TB, and this difference is called as delta TB, that is elevation in the boiling point, right? I have mentioned it like this. You can also mention it like a curve, right? Solvent, solution, it has decreased. Where this line touches the atmospheric pressure, that will be your boiling point, because vapor pressure, when it is equals to 1 atmospheric, that defines the boiling point, right? Okay. Next, guys, we have depression in freezing point, right? Next we have is depression in the freezing point. Let's talk about that, everybody. Let's talk about depression in the freezing point. Yes, students, let's talk about depression in freezing point, right? That is also quite similar. Now, delta TF is actually depression in freezing point. What is freezing point? When vapor pressure of that component is equals to vapor pressure of solid, right? We know that vapor pressure of liquid is always greater than, this is vapor pressure of liquid. It is always greater than vapor pressure of solid. This is vapor pressure of solid. Okay, this is vapor pressure of liquid, this is vapor pressure of solid. So these two are equal to each other, right? Now in this way, what we will write, when they are equal, they should be equal, that defines your TF0, right? Now we know that vapor pressure, this is vapor pressure of like solvent, vapor pressure of solution always is less. Why? Because vapor pressure decreases on adding non-volatile solute. Now this is going to be TF, right? And now we can see that TF is less than TF0. That means there is a decrease in the freezing point. There is depression in the freezing point. That is called as delta TF. That is equals to T. Larger value means TF0 minus TF. If you see this here it was TB minus TB naught. Here it is TF naught minus TF. That is the difference. Molality is same, that is W2 by M2. This is divided by W1 multiplied by 1000. That is defined as molality, right? Okay, and this is the graph that you will make. This is frozen solvent, right? Now this is your liquid solvent, right? Where when you have not added non-volatile solute, this is when you add non-volatile solute, vapor pressure will decrease, and this is the point of TF naught, and this is the point of TF, right? And the difference that you have is delta TF, right? Okay. Yes, everybody. Next is osmotic pressure. Now let's talk about osmotic pressure. What is osmotic pressure? Let's talk about that, right? So guys, if you see in osmotic pressure, what you have, the minimum pressure required to prevent the flow of solvent from a lower concentration to higher concentration, right? So what we do, this is a semi-permeable membrane, right? This is a semi-permeable membrane. So in one case you have only solvent. Here you have solute plus solvent. So only solvent particles will move from their lower to higher concentration. Solvent lower to higher means this way it will move, right? This is the direction where solvent particles will move from lower to higher concentration, right? Now solvent particles are moving from their lower to higher concentration, that we can see. But what is the next thing, right? This movement is called as osmosis, right? But when you want to apply an external pressure here to stop that movement, that is called as osmotic pressure. And when this pressure is more than osmotic pressure, then it becomes reverse osmosis, right? So here the pressure, external pressure that we apply to stop osmosis, to stop the flow of solvent particles, that is called as pi, that is osmotic pressure, right? Wait a minute, this is called as osmotic pressure, this one, osmotic pressure. Now osmotic pressure is equals to CRT, where this C is the molarity. Molarity is number of moles divided by volume in liters, right? This formula also is very important, right? Okay. Yes, everyone. Do let me know if that is clear to all of you or not. Yes, everybody. Do let me know if that is clear to all of you or not. Right? Students, do let me know if that thing works for all of you or not, so that we can do the next part here, right? Now, isotonic solutions are where both solutions have same osmotic pressure. If one solution has more osmotic pressure as compared to the other, then the one which has higher osmotic pressure is hypotonic. This will be hypotonic. The one which has less will be hypertonic. The one which has more osmotic pressure will be hypotonic. One which has less osmotic pressure will be hypertonic. Now, when you add Van Hoff factor, right? Because if there is dissociation or association, we'll have to add a factor called Van Hoff factor in front of all the concentration terms. So this I will be in front of everyone, that is Van Hoff factor, right? And what is the value of Van Hoff factor? In case of association, Van Hoff factor is always less than 1. In case of dissociation, Van Hoff factor is always greater than 1. Right? Now the formula of Van Hoff factor in terms of degree of dissociation will be these two. where n is number of particles associated. Like in case of dimer, n will be 2. In case of trimer, n will be 3, right? So here n will be number of particles dissociated. Number of particles dissociated. Like in case of, let's say you have NaCl. NaCl is dissociated to 2 particles. Al2SO4 thrice. Here you will have Al3 positive 2 times. You will have SO4 2 negative 3 times. So total N will be equals to 5. Okay. So number of particles in which it is being associated or dissociated. Alpha is the degree of dissociation or association that will be given in the question only. From there you will calculate the value of I depending upon whether it's association or dissociation. You will put it here and respective colligative properties you can answer, right? If there is no information about this solute, then I is equals to 1. And for a non-electrolyte like you have urea, sucrose, glucose, I is taken as 1, right? But for a electrolyte, it is not equals to 1, okay? Let's talk about some questions here, guys. Let's talk about some questions. I see very few students. Chalo, let's talk about some questions here. Let's see if you can answer this. Relative lowering in vapor pressure is directly proportional to number of ions present in the solution, right? Is it? Relative lowering of vapor pressure of 0.1 sugar solution is less than 0.1 urea. Okay. Molarity is same, right? Relative lowering in vapor pressure we are talking about is less than that of 0.1 molar urea. Now when we talk about sugar, right, that depends upon whether they are talking about glucose or sucrose, or they are talking about something else which can be dissociated, right? So let's talk about this. Vapor pressure is directly proportional to the number of ions present in the solution. Yes, it depends upon the number of ions present in the solution. So assertion will be correct here, right? Relative lowering of vapor pressure of 0.1 sugar solution is less than that. That will not be correct here because Van Hoff factor of both will be equals to 1, right? We are saying that both have same molarity, then why it will be less or one will be more? So that is incorrect statement. So answer will be assertion is correct, reason is wrong here, right? Now let's see a numerical based question here. The correct option for the value of vapor pressure of solution at 45 degrees Celsius with benzene to octane in molar mass ratio, right? Vapor pressure of benzene is this and that of octane is this. Assume it's an ideal gas, that means PT is equals to P naught A mole fraction of A plus P naught B mole fraction of B. Now they are saying that the molar ratio, that means number of moles of 2 by number of moles of 1 will be 3 by 2, right? That is given to you, right? So this ratio is given to you, P naught A is given to you. Let's say benzene is A and octane is B. Then this is P naught A and this is P naught B. Now you will just have to put all the values here and you will get your answer, right? Number of moles of benzene to octane is given to be 3 by 2. You will see that the ratio, if I say number of moles of 2, this is number of moles of 1. If I take number of moles of 2 is equals to 3x, number of moles of 1 is equals to 2x. So mole fraction of 2 will be equals to 3x by 5x, that is 3 by 5. Number of moles of 1 will be number of 1 minus 3 by 5, that is 2 by 5. Okay. Now you have mole fractions. P naught A, P naught B is given to you. Put in all the values and you will get your answer by just applying the Raoult's law here, right? Okay. So that's how a simple question can be asked to you. Now let's see another question, that is assertion reasoning questions based on colligative property that has been asked to you. Right, let's talk about that. So here the question says osmotic pressure is a colligative property. Osmotic pressure. Yeah, that's true, right? Osmotic pressure is proportional to molality. No, that's not true, right? So we can say that A is a correct statement, but R is false here, right? Because, wait a minute, because it is directly proportional to molarity, not molality, right? So answer will be C is the correct answer here. Next question is for a 5% solution of urea. Now they have given you a question that is asked in CBSE 2020. This is based on fourth colligative property, that is osmotic pressure. Let's read out the statement. For a 5% solution of urea, molar mass is given. Calculate the osmotic pressure at 300. See, urea means Van Hoff factor will be equals to 1, right? Molar mass is given to you, right? Calculate osmotic pressure, R is given to you, right? Okay. Now, if you see osmotic pressure is equals to CRT, you should know what is molarity and you will be able to answer this question here, right? So, how do you calculate molarity? Molarity when they have given 5% solution of urea. So, percent of solution is given to you, that is 5% solution of urea is given to you, right? So, we can say from this 5% that 5 gram in 100 milliliter solution. This we can write. 5% means this will be weight by volume. You can write because it's not clearly mentioned here. So we can assume it as 5 gram in 100 milliliter. So when I say 5 gram, right? So what I'll take as, I'll just show you. See, volume of the solution will take as 100 milliliter. So we'll say pi is equals to number of moles divided by volume in liter. If volume is in milliliter, then I'll have to multiply this by 1000. This is RT, right? Now this will be equals to W2 by M2. This is volume in milliliter multiplied by 1000 into RT. This is just based on one D code, right? Now if you see volume, this we have taken to be 100, right? This is given to be 5. This urea is given to be 60, that is having 60 molar mass, right? R is also given to you in the question, that is 0.0821, right? You should also know the value as it is. Temperature is also given to you, if I can see, yes, 300, right? Temperature is also given to you. This is also 0.0821, or you can take it as 1 by 12. Okay, you can also take this value as 1 by 12. 1 by 12, guys, it has the same value. Okay, you can also take it as 1 by 12. That will be easy for you to do the calculation. I'll give you a trick. In the exam, when you are writing the value of R in the subjective exam, because this is subjective exam, don't write the value of R as 1 by 12. But while doing calculation, do it as 1 by 12. Okay? Yes? Okay, understood. So put all the values and you will get your answer here. Tell me. Put all the values and you will get your answer. Only this part was important here, that how do you write 5%? How do you decode 5%? That means 5 gram in 100 milliliter, right? That's how you decode this. Next question from here is, a raw mango placed in concentrated salt solution loses water via osmosis. We are saying that a raw mango is shrinking via osmosis because solvent particles are moving, right? Lose water via osmosis and shrivel into pickle, right? We have pickle because raw mango will shrink. Wilted flowers revive when placed in fresh water. You have a rose, right? You put it in fresh water, it will swell up, right? So what will happen? It will regain its charm. A carrot that has become limp because of water loss into the atmosphere can be placed in the water, making the firm once again. So like raisins are, you know, swelled up, right? Same thing, we are talking about osmosis. Water will move its cells through osmosis. When placed in water containing less than 0.9% salt, blood cells swell due to flow of water in them by osmosis. In our blood also, we need specific, like whenever you have intravenous injections, right? You need a certain percentage in your blood, that is 0.9%, right? That is needed. If you have the concentration of that is less than 0.9%, right? Then what will happen? Blood cells will swell, right? But if you have more than, this is a very important question in itself, more than 0.9, blood cell will shrink. Okay, right? So here you have hypotonic and here you have hypertonic. So this is hypotonic solution, this is hypertonic solution. Hypertonic, the one which has more osmotic pressure, because it has more percentage, that means more osmotic pressure will be there. So hypertonic solutions always shrink, right? So now they are saying that people taking a lot of salt or salty food suffer from puffiness, edema. What is the reason behind this first question? Second is the preserve. This is actually a 5 marks question, okay? The preservation of meat by salting and of fruits by adding sugar protect against bacterial action. How? Then they are asking you why the direction of osmosis get reversed if the pressure larger than osmotic pressure is applied to the solution site. Write one application. So let's talk about all of this one by one. First question is, people taking a lot of salt or salty food suffer puffiness or edema. Why? Because of people experience water retention in tissues, right? And intercellular spaces due to the osmosis, right? Due to osmosis, due to more salt here, they will suffer from water retention, and that is the reason they suffer from puffiness, right? They have water retention in their body because of more salt, right? Right? Then you have the preservation of meat by salting. Now we always say that you add to the meat you add salt, it will be preserved for a longer time. Why? Through the process of osmosis, a bacterium on salted meat or candied fruit loses water, shrivels and dies because of osmosis. When you add salt, the bacteria, it will lose water, it will get dehydrated, and that is the reason it will shrink and it will die, right? Then third is, why the direction of osmosis is reverse pressure of large, this is applied to the solution side. One application is desalination of water, that is same in our RO system. So you have this semi-permeable membrane, right? This is the solution side, this is, let's say this is the solvent, this is solution side. So always solvent particles are moving from solution to solvent, but in the reverse osmosis they are moving in the opposite direction, right? This is RO, reverse osmosis, right? So here let's say you have only water, here let's say you have NaCl plus water, right? So what will happen, right? What will happen here? Wait a minute. The solvent particles, no, not like this. Wait a minute. Wait a minute. Wait a minute. Lower concentration to their higher concentration, no? It will start moving. Wait a minute. Solvent particles are moving from, just give me a second, flow from a lower concentration to higher concentration of solution, है ना? This also I made opposite, wait a minute. Let me just write it, draw the diagram again, right? Let me just draw the diagram again. You know, it was opposite, right? So let me just draw it again. What exactly we have here is that in case of osmosis, you have a beaker, right? Then you have a semi-permeable membrane here. Then you have a semi-permeable membrane. Now here let's say you have only the water, and here you have NaCl, salt plus water, right? So solvent particles are always moving from their higher concentration to lower. From solvent higher concentration, this is solvent high concentration, this is low. This is actually osmosis. This direction that I am showing here is osmosis. And what is reverse osmosis? That is this direction. This direction which I am showing by white line is actually reverse osmosis. This that I am showing by white line is actually reverse osmosis, right? Where in case of reverse osmosis, from low concentration of solvent to high concentration of solvent, it will move. Here I am talking about the concentration of solvent only, I am not talking about the concentration of solute. Now what will happen? When NaCl, when solvent particles, water particles are moving in this direction, that means here you will be left with, in the end you can say what you will be left with in the case of RO system, what will happen? Only in this direction the water particles will move. Water particles will move only in this direction, and here you will be left with only salt, and here you will have water. So salt will be eliminated from the water, and that is called as desalination of water, which happens via reverse osmosis, right? Pure solvent particles flows out of the solution through semi-permeable membrane, right? Okay, understood everybody? Yes. Now let's talk about next chapter, that is electrochemistry. Now let's start some questions of electrochemistry. Okay, we'll do that, right? Now let's start with electrochemistry. Here I have picked, since solution I have almost done most of the topics. Reason being that was, you know, it's still colligative properties still predictable, but others are very unpredictable. They can also ask from ideal, non-ideal. They can also ask from Henry's or Raoult's law, right? But in next chapters I have picked some very specific topics. Like from electrochemistry you have Nernst equation, a very important topic, right? That is E cell is equals to E naught cell minus 0.059 by n log of QC, where log of QC is product by reactants, right, raised to power the stoichiometry, right? And we know that, guys, what is E naught cell? E naught cell is equals to E naught cathode reduction potential minus E naught anode reduction potential, right? And when we say at equilibrium E is equals to 0, we can say E naught cell, when this is equals to 0, E naught cell becomes 0.0591 by n, and at equilibrium QC becomes equals to Kc. So this will become Kc, and that is another formula that you have between E naught cell and Kc. This is also another important formula that you have, right? Okay. And now in all these cases, what is N? N is the N factor. It is number of electron gained or lost, right? In a redox reaction, what are the number of electrons that you gain or you lost? That is called as N factor, or it is also called as valency factor, right? Okay, let's do some questions based on that so that you understand what exactly we are talking about, because these kind of questions, just by telling you that this is the formula, you won't be able to understand that. Okay, you have to get into, you have to see the questions, what kind of questions they ask you, right? So calculate the potential of hydrogen electrode in contact with a solution whose pH is 10. See guys, pH 10. Now here, now those students who completely don't understand class 11th, that's why they find class 12th difficult, right? But don't worry, that's why we are taking these sessions specially for CBSE students. So guys, pH is minus log base 10 of H positive, that is equals to 10. Right? Now if you see this formula here, I'll tell you how to write this formula. This formula is exactly, wait a minute, this formula is exactly E cell is equals to E naught cell minus of 0.0591 by n factor log of Kc, log of Qc, right? Now see, how do I write it? Always write the reduction potential value, right? Always play the game in reduction potential. So always H positive, it gains 1 electron, it will become H2. For this 2, it will be 2. For 2, you will have 2 electrons, right? Now, SHE, standard hydrogen electrode, whether it's oxidation or reduction, it is always going to be 0. So this value is going to be 0. So E cell is equals to 0 minus 0.0591 divided by 2. N factor is 2 because 2 electrons it is gaining. Log of Qc. This is one of the difficult questions that I have given you here, right? Okay, because I want you to think about higher things. Log of Qc is product by reactants. This is P of H2, that is on the product side. On reactant side, you have H positive concentration raised to power stoichiometry, that is 2. Now pressure is given to be, when nothing is given, even then you will take pressure as 1. This is given to be 1, right? So you will write it as E cell equals to minus of 0.059, or you can also write it like this. Okay, minus of 0.0591 divided by, I will not solve this, right? This is log of 10 H raised to power this minus 2. Log of H raised to power minus 2, this power will come in front and you will have minus will cancel, you will have 0.591. This is divided by 2, this is minus, this is multiplied by 2, this will cancel, this will become log of H positive. You know the value of log of minus H positive, right? So what you will do, we'll put one more minus here, this will become minus 0.0591. This is minus log of H positive. That is nothing but that is given to be 10. So it is minus 0.059 multiplied by 10. And the answer will be minus 0.591. Okay? Yes, everybody. So you'll have the answer here. Right? Okay, students, tell me if that is clear to all of you or not. Right? So these kind of questions they can ask you, as you can see, right? Same question they have asked, but here they have asked the oxidation potential of electrode. Bacha, see, here you have gained the electron. So this I am calculating the reduction potential, because here I am putting a reaction where I am talking about gaining the electron. So I have calculated the reduction potential. This is the reduction potential. If I want to calculate the oxidation potential, that will be minus of reduction potential, that will be minus 0.591, that will be 0.591. That is, this is going to be the correct answer. Now, this question can be asked in terms of MCQ based, but most probably this will be asked in subjective, in a numerical based, right thing, right? Okay. Now, let's see this question of CBSE 2022 based on Nernst equation. Let's talk about this one as well. like what they have asked you, how to calculate T9. We will talk about that. We will talk about that in the next chapter, that is chemical kinetics, right? So calculate the EMF of the following cell. Now see, I'll tell you how to read these kind of questions. But just see this question where pH they are relating with the Nernst equation. This is very important. That's why I have specially picked up this question. Okay. Now, if they ask you this category of question, that means the exam is a good level exam they have asked you, right? But if they ask you this kind of question, this is a very general question that is going to be there in your exam. This has been like repeatedly asked, same category of question. So let's see how to read the question firstly, right? So as I told you, Nernst equation is not about theory, it's about questions, right? So if you see, solution chapter was more about theory. So that's why I have done theory more there. Here more questions I am doing, right? So here you have, always remember in cell representation, this is always anode side and this is always cathode side. Always on the right side you have cathode, on the left side you have anode, always in the cell representation, right? So that means at anode you have zinc, 2 zinc positive, 2 positive, and here you have Ag positive, 2 Ag. Now zinc is getting converted to zinc 2 positive by losing 2 electron, that is anode. Ag positive is getting converted to Ag by gaining 1 electron, Now the number of electron lost and gained should be same. So that's why I'll have to multiply this by 2, right? That means the overall reaction will become this one, right? This is at anode and this will be at cathode. N factor is equals to 2 here because number of electron gained and lost is 2, right? E naught value is given to you. Now I told you that E naught cell is E naught cathode. Cathode means Ag. And you have to write the reduction potential of both. Now ma'am, how do I know that this is reduction potential? How do you know? Always in case of reduction potential, oxidation number will always decrease. Here plus 1 to 0, that means it is decreasing. Here it is plus 2 to 0, that means it is decreasing. That means both are reduction potential. Now I know that this one is cathode and this one is anode. So I'll write cathode firstly, 0.08 minus of anode. Anode is minus 0.76, right? You'll add these two values here, 0.08, this will be plus 0.76. right? And you will have your answer of E naught here, right? Then let's put the values in E naught cell, right? What is E naught cell, everybody? What is E naught cell? Sorry, E cell is equals to E naught cell. E naught cell we have just calculated here, minus 0.59 divided by N factor is 2, log of product by reactant. On product side you always see the ions, product by reactants. So this is Zn2 positive concentration divided by Ag positive concentration raised to power stoichiometry, that is 2. Now Zn2 positive is given to you, Ag positive is given to you. Put all the values and you will get your answer. Okay, put down all the values here. This is E naught cell. This is N factor, this is Zn2 positive divided by Ag positive. Put all the values, solve it and you will get your answer here. Now question can be, ma'am, this I can do, ma'am, this is plus minus. Ma'am, how to solve this thing? How to solve this thing? Right? So this is log of, this is 10 raised to power minus 2, right? This is 10 raised to power minus 3 square. That is nothing but 10 raised to power minus 6. 10 raised to power minus 6. You take it there, it will become 10 raised to power plus 6, that is nothing but log of 10 raised to power 4, right? This is directly they have written 10 raised to power 4. Okay guys, let me know if that is clear to all of you or not, right? Yes everybody? How to calculate this? Tell me guys. This is a very important category of questions, right? Now, another category in Nernst equation that they are asking you right now is the relation of delta G and E naught. So, delta G is equals to minus NF E cell, delta G naught is equals to minus NF E naught cell, right? They can give you the value of E naught cell, ask you delta G naught, like simple. What is the value of 1 Faraday? 1 Faraday is always equals to 96500 approximately. So directly you can know the value. N is N factor, number of electron gained and lost, right? Now whenever delta G is negative, this we know from thermodynamics that you did in class 11th, right? So I'm not expecting this from, I'm expecting that you don't know anything about class 11th, right? So delta G negative means it's a spontaneous process. Always delta G positive means it's a non-spontaneous process. Delta G equals to 0 means it is equilibrium, right? So when delta G is negative, if you keep this relation in mind, minus NF E cell, if this is negative, this will become positive. If this is positive, this will become negative. That's why in terms of E cell, the spontaneity and non-spontaneity will be given by E cell positive, spontaneous, E cell negative, non-spontaneous, right? Okay. Now, three relations. This is delta G is equals to minus NF E cell, E naught cell. Delta G, this also I told you that this also you can write it as E cell is equals to 0.059. When you put the value of RTF in Nernst equation, that becomes 0.059 by n factor log of Kc, right? This for numerical purpose we write it like this, and this also we can write it as delta G naught is equals to minus 2.303 RT log of Kc. So these are the three relations, this one, and this one, that you must remember for your board exam, right? A direct question can be asked here. You don't have to do anything, you just have to put in the values here, that's it. I'll show you how. We'll talk about some questions related to this. Let's see. First is, if the reaction quotient is greater than the equilibrium constant, what is true about Gibbs free enthalpy, right? Now this question has been asked from reaction quotient, that is QC, is greater than Gibbs, if the reaction quotient is greater than equilibrium constant, what is true about Gibbs free enthalpy? Let's talk about this in terms of formula. If Q is greater than K, right, the reaction has exceeded the equilibrium state, right? That means it is moving. It will proceed non-spontaneously. It means that delta G must be positive. So one thing you should know, this is again from class 11 that they can ask you here, right? This is how they can confuse you for your board exam as well. Right, so always remember when you have this is QC, when QC is equals to KC, that is at equilibrium. When KC is greater than QC, it's a forward reaction. When KC is less than QC, it's a backward reaction. And now they are saying that Q is greater. When Q is greater, that's a backward reaction. A forward reaction will always occur spontaneously. A backward reaction will always occur non-spontaneously, and that is why here delta G will be positive, here delta G will be negative. Is that clear, everybody? Is that clear? Right? Tell me. It's an important question for your board exams, right? Mark it important, right? That's how they can relate, and you know, that will be very important. So delta G is positive. Now see next question, that is a numerical based question, that is calculate the maximum work and log Kc. So maximum work is nothing but they are asking you the value of delta G. Log Kc and delta G relation you should know, right? for the given reaction, this is the reaction, so relation you should know. The relation between delta G and Kc is nothing, this is delta G is equals to minus N of E naught cell. So here you will calculate the value of delta G from here. Wait a minute. What they have given you. Directly also you can put, they have asking you delta G, they have given you log Kc. Acha. They have given you delta G and they are asking you log Kc here. Both they are asking you. Acha, I'm so sorry. They are asking you both the things. Delta G also and log Kc also. Nothing else they have given. So you should know the relation between delta G and E naught cell. You should know the relation between Kc and E naught cell. Both the relations will be applied here, right? So we know both the relations, that delta G is equals to minus NF E naught cell. This is first relation, and the second relation of E naught and log Kc is this one, right? This relation you can also write it as E naught cell is equals to 0.059 divided by N of log Kc. This also you can write here and you can put in the values. Now let's see how do you calculate the value of E naught cell from the equation that is given. Now here first you will have to identify which is cathode, which is anode. So N is getting converted to nickel, is getting converted to nickel 2 positive, it means it is losing 2 electrons. Ag is getting converted to Ag, that means plus 2 0. That means here it is gaining the electron, reduction is taking place, oxidation number is decreasing. 2 will be multiplied because number of electron gained and lost should be same, so N factor will be 2. This is anode and this is cathode. This is cathode. So you will say that this is cathode. No, this is anode. Wait a minute. This is anode and Ag is cathode. So E naught cell is reduction potential of cathode minus anode. Are these two reduction potential? This is from plus 1 to 0. This is from plus 2 to 0. So both are oxidation number is decreasing. Both are reduction potential. So this is E naught of cathode, that is 0.80, minus of E naught of anode, that is 0.25. You will add this 0.80 plus 0.25 and you will have your answer here. Right, everybody? Tell me. Right? That's how you will calculate the value of E naught cell, right? Then you put the value of E naught cell here. N factor is 2, Faraday is 96500. E naught cell you have calculated here. N factor is 2, Faraday is, dekho beta here, so directly this formula you will apply. N factor is 2. E naught value you have calculated, you will solve the value of log Kc and take the anti-log and you will get the answer. Now some of you might, firstly though you have enough time to to practice how to calculate anti-log, right? Okay, but still if you're like, ma'am, I don't think so I'll be able to do that, I'm weak in calculation, this or that, at least you can do till here. If you do till here, even then they will, if let's say this question is of, let's say 5 marks, they will give you 4 marks, like only for this thing that you have done, right? Okay. So don't skip any question in your board examination. They are definitely going to give you marks, even if you write the formula and put the values, right? For calculation, they can, take out 0.5 or 1 marks. But I will definitely not advise you for those who want to get like 99 marks in, like 99, I would say 65 plus marks in your chemistry exam. For them too, they should do calculation as well, right? If you want to get like full marks in chemistry. But if you're like, okay, I'm not good in calculation, what if in the panic mode I'm not able to do calculation correctly, but still they will give you marks for that. For putting the formulas, putting the values, trying to do that, they will give you the marks, right? That's the benefit, right? Okay. Yes, Nishant, kindly focus here, right? Now guys, next topic is conductance and conductivity, right? So here you should know few things, that is what is conductancy. Firstly, conductance will be represented by capital G, that is 1 by R. R is resistance. Conductance is the flow, resistance is to stop, right? Rho is resistivity and K, that is called as kappa, that is conductivity. Now there is a formula which equates all of them, that is you can say R is equals to rho L by A, right? Okay, so here actually wait a minute, R is equals to rho L by A, that is in the form of resistance and resistivity. This you must have done in physics as well. When you write this in terms of conductance, this becomes 1 by G, this becomes 1 by kappa. As conductivity, this is L by A. Now guys, remember one thing, there is a thing called G star, that is cell constant, that is nothing but that is L by A, right? Now this is a pure game of formulas. So that's why when you put this value 1 by G is equals to 1 by kappa, this is G star. You will see G into G star is equals to kappa, which is again a very important relation. This is very important. This one you must remember, this one is very important, okay? This one is very important. These two relations you must remember, right? And you should know which is what, like which is resistance, what symbolize, which denotes conductivity, resistivity, conductance, resistance. You should know the symbols here, right? Okay. Now this is about the symbols and the units here, right, that you can go through. Now next, see, this I have already told you what is G. G star, that is cell constant. This formula also we know, this formula also I have told you, this also I have told you. Now let's see, there is a thing called molar conductivity and equivalent conductivity. See guys, when you talk about conductance, conductance is for overall solution, that is called as conductance for a volume V, right? You have a solution, you calculate the conductance of that overall solution. You have a beaker, you want to calculate the conductance of overall beaker, that is called as conductance. If I say that calculate the conductance of length 1, breadth 1 and height 1, that means volume should be 1. For a unit volume, the conductance becomes conductivity, right? That is specific conductance. When we talk about molar conductance, we say conductance of not 1 milliliter. We don't say the volume. We don't talk about the volume. We only talk about moles. Conductance of, when number of moles are 1, for 1 mole, that is called as molar conductivity. For 1 gram equivalent, that is called as equivalent conductivity. And these are the formulas that you must remember. Very important. Up to CBSE, you will use this formula only, but chances, see, in solutions, mostly things are in centimeter. That's why your kappa will be in centimeter only. If kappa is in centimeter, you will apply kappa into 1000 by molarity, kappa into 1000 by normality, and usually they ask you molar conductivity, not equivalent conductivity, right? And when you have kappa in meters, then formula 1000 will be in the denominator. But most of the cases you will see this formula only. Till now in CBSE they have asked this formula only. Even in NEET exams they have asked, NEET or JEE exam they have asked this one only. But yes, in JEE sometimes they confuse you by giving kappa in per meter, in meter as well, right? So that's why I am telling you that for CBSE remember this particular formula, right? Okay. Then always remember for theory based questions that when Dilution, when you add water, concentration is inversely proportional to dilution, concentration decreases, conductivity will always decrease, and molar conductivity will always and always increase in this case. So now we have two types of things, two types of electrolytes. One is strong electrolyte, then there is weak electrolyte. In strong electrolyte already there is 100% dissociation. So that's why what we will see, that as concentration is decreasing, concentration decreases means dilution increases. That means molar conductivity increases. So it is increasing, right? Okay. And it is shown by this on-Sagar equation, that is molar conductivity at concentration C is molar conductivity at infinite dilution A into under root C. So when you compare it, mole fraction will become slope will become minus A, and intercept will become molar conductivity at infinite dilution, right? But for a weak electrolyte, the graph is not same. The graph is not cutting anywhere. There is no intercept, right? It is suddenly increasing and exponentially it increases, then it increases such a high rate that it becomes parallel to the y-axis. So there is no intercept. You can't find the value of infinite dilution molar conductivity in case of weak electrolyte. You can't find that, right? That is why you have Kohlrausch law, from where we find out the infinite dilution molar conductivity, right? It says that this they have asked you in like case based questions, they can ask you these kind of things, right? So it says that molar conductivity of any solution at infinite dilution is equals to the conductivity of individual ions. So you can split it into individual ions, right? And it says that size is directly proportional to molar conductivity at infinite dilution, except for hydrogen. Hydrogen has maximum infinite dilution molar conductivity. Hydrogen has maximum. So if I want to write sodium and lithium, which has more size, sodium, so that's why sodium will have more molar conductivity at infinite dilution as compared to lithium. But hydrogen will always have maximum, right? Because that is an exception, right? Because that is one of the exceptions, right? Okay. Now let's see what kind of questions they can ask you from here. Yes, everybody? Oh God. Hello. What has happened? From how long am I stuck? Oops. Am I audible to all of you? Am I audible to all of you or not? Tell me. Am I audible, guys? Hello. Achha, now is it fine? Now is it fine? Now is it working? Chalo, good. Okay, so what I was telling you there, I'll just repeat it. So here I told you about the thing. Now I'll do it fast, okay? So here I told you about that resistance and conductance are inversely proportional, conductivity and resistivity are inversely proportional, right? And when you solve this, you get a formula where G star is cell constant, that is L by A, G is the conductance, kappa, K defines the conductivity, right? Then we talked about the relation of molar conductivity and kappa and molarity. Now this relation you are going to use when kappa is given in centimeter, and for CBSE level kappa is given in centimeter only. So you will always use this particular relation, right? Now then we talked about that how on dilution kappa will always decrease and molar conductivity always increases. So for strong and weak electrolyte, for both molar conductivity will increase, but for strong electrolyte you will have a point where you can see a specific point where you will be able to find the molar conductivity at infinite dilution. But in case of weak electrolyte, it rises so rapidly that you don't find, you are not able to find the molar conductivity at infinite dilution. So that is why you have Kohlrausch law, where we say that, for example, you want to find out the molar conductivity of CH3COH. That is equals to molar conductivity of CH3CO negative plus molar conductivity of H positive, right? For example, they have given you molar conductivity of NaCl, they have given you CH3CONa. Let's say they have given you Na. Molar conductivity of Na, molar conductivity of Cl, NaCl they have given you, right? Let's say they have given you molar conductivity of strong electrolyte, that is NaCl. They have given you molar conductivity of HCl, right? And they have given you molar conductivity of CH3COONa. So what you exactly do, you add HCl and CH3Na and you subtract NaCl from there. Because here, this H you have to save, this CH3CO you have to save, because molar conductivity of CH3COH is molar conductivity of CO negative plus molar conductivity of H positive. This Na will be cancelled by this one, this Cl will be cancelled by this one, and that's how you write it in the form of Kohlrausch law, right? So molar conductivity of a weak electrolyte you can find through the molar conductivity of strong electrolytes by adding and subtracting, right? I have given you one of the examples, right? Why we have added these two and subtracted this one? Because this is Na positive and Cl negative. This is basically, this is bacha Na positive, Cl negative. This is H positive, this is Cl negative. This is CH3CO negative, Na positive. So you just need to have this one and this one. For that you need to cancel these. So that's why I have added these two, I have subtracted NaCl from there, right? Okay. Yes, everybody will do that, don't worry, right? So many things are planned for you, don't worry about that, right? Your SRM, VIT right, BITS, Pilani, every like BITS exam, all of them will be here only, don't worry, we'll do preparation for that as well, right? Conductivity decreases with decrease in concentration of electrolytes. So conductivity, now he is talking about conductivity. Conductivity, now this is your CBSE 2023 question, which says that conductivity decrease in the concentration. We know that as dilution increases, concentration decreases. When you dilute, conductivity decreases, right? So dilution means concentration you decrease, conductivity also decreases, that is actually correct. Now number of ions per unit volume that carry the current in a solution decreases. Now why conductivity decreases when you dilute it? See, when you have a solution, we are talking about this much volume, right? Earlier in this much volume you had more number of ions, but when you add water, water will have space in these ions, in this 1 unit volume, water molecules will also be added. So the number of ions of that solution will decrease. So that's why number of ions per unit volume that carry current in a solution decreases. That is also true. So E and R both are true and R is the correct explanation of A. So answer will be A is the correct answer here. Right, everybody? Is that clear? Is that clear? Yes. Now let's talk about next thing, that is chemical kinetics. Let's talk about the laws here. Let's talk about the laws. See, first question that is very easy. I have not told you this in important topics, but I thought that it's very easy, then let's do this, right? So, one thing you should always remember, whenever you are writing the rate of reaction, right, you're always dividing it with the stoichiometry. Whenever you are writing rate of appearance or disappearance, you are never dividing it with the stoichiometry. That you should remember, right? Okay. So, rate of reaction is always concentration by time, dB by dt, dA by dt. Whenever we talk about a reactant getting consumed, it is always having, whenever a reactant is getting consumed, it will always have minus, so it will be minus here. Wait a minute. Okay, here it is written opposite. It should be minus here and it should be plus here. Whenever a product is getting formed, it will be plus. Whenever a reactant is getting consumed, it will be minus. For rate of reaction, you will divide it with stoichiometry of that reactant or product. For simple rate of appearance or disappearance, you will not divide it with the stoichiometry, right? Okay. So, based on this, we have a question of CBSE based on this very simple concept, that is, for a reaction that is given, the rate of reaction of this is equals to. Let's see this, right? Now guys, see, rate of reaction you have to write, rate of reaction, right? This will be rate of reaction. Whenever you write for reactants, you divide it minus dB by dt. For products, you always add positive, that is dB by dt, right? When you are writing rate of reaction, you divide it with the stoichiometry. This is 1 by 3, this is 1 by 2. Now they are asking you what is the value of dB by dt here. dB by dt positive is nothing but minus 3 by 2 dA by dt, and that is going to be the value minus 3 by 2 dA by dt, that is A is the, wait a minute, why? Achha, dB by dt, you are, my mistake. Here it will be minus 2 by 3. Yes. dB by dt we are writing now. So it will be minus 2 by 3. So answer will be B is the correct answer here. Right. So based on a very simple concept, they have asked you an MCQ based question here where B becomes the correct answer. Right. Now a next question is based on this rate law only. The rate of the reaction is concerned with decrease in concentration of reactants or increase in concentration of the product. Reactant is decreasing, product is increasing per unit time. Now this is case based question, okay. It can be expressed as instantaneous rate at a particular instant of time or average rate over a large interval of time. Average rate also you calculate by delta. Instantaneous also you calculate by dB by dt, dA by dt. Mathematical representation. Rate of reaction is given by rate law. Rate constant order of the reaction can be determined from rate law or its integrated rate equation. Okay. What is the average rate? The question that they have for always case based question, I will give you one hint. Never see the paragraph first. For a case based question, never go through the paragraph first. Firstly see the questions. Maybe you don't need to read out the paragraph, right? So it is like wasted of time to read the paragraph in case based. Firstly see the question, then read out the paragraph, right? So that you can identify if something useful is there in the paragraph or not. First thing, what is the rate of average rate? Write two factors that affect rate of reaction. What happens to rate of reaction for zero order? What is the unit of K for zero order? So these are the questions that are based on some general things. So let's see. So we know the first is what is the average rate? That is change in concentration of reactant or product per unit time. That is, you can say minus delta R by delta T or plus delta P by delta T. That is the average rate. That is the average rate. right? Then second is write two factors affect the rate of reaction. It is affected by the concentration of the reactants. It is affected by surface area. Surface area is more, reaction will be faster. That's why we always use powdered form. Some things we use in powdered form to increase the surface area, right? Then catalyst always, a positive catalyst increases the rate of reaction. Temperature also increases the rate of the reaction. If temperature increases, rate of reaction will be more, right? So you can pick any two. What happens to rate of reaction for zero order reaction? For zero order reaction, rate is independent of the, this we'll talk about later. And this also, this make a question mark here, right? This I'll talk about in the next part. See, I'll talk about this. Wait a minute. Let me just firstly teach you about that. Dekho. What is rate law expression? What is rate law expression? If you talk about rate law expression, rate law is R is equals to K. This is reactant raised to power stoichiometer, raised to power order, right? Now this order is defined by n, that can be 0, 1, 2 and so on. Usually we talk about zero order or first order reaction. So for a zero order reaction, for n is equals to 0, when I say in this case n is equals to 0, rate becomes K raised to power A0, right? Reactant raised to power 0. So we can say R is equals to K. So rate becomes independent of the initial concentration, that you can say, right? Then what happens to the unit of K for zero order reaction? Achha, this also I'll just write it here, like this is the rate constant. This also actually I have written it here. I'll just pick that slide from there to here, right? So that things are in a better, way we have learnt, right? Okay. So rate law expression for any reaction will be rate is equals to rate constant. This K is rate constant. Reactant raised to power order of the reaction, right? A raised to power X, B raised to power Y. X and Y can be the stoichiometry, cannot be the stoichiometry, right? X plus Y is defined as order of the reaction, and in terms of order of the reaction, units are written as K is equals to mole per liter raised to power 1 minus n per second. You put the value of n is equals to 0, this will become mole per liter per second. You put n is equals to 1, this will become per second. You put n is equals to 2, this will become liter per mole per second, okay? That's how it will change. And T half means when 50% is consumed. When 50% of the reactant is consumed, T half is directly proportional to A naught or initial concentration raised to power 1 minus n. Okay, that is the general relations that are very, very, very important. Based on this general thing, they will ask you questions here. Based on these two very simple formulas, they will ask you the questions. Okay, right? Okay, Jayshant will definitely do that. Right now, please focus here. We'll do that. Okay. Now, what is the unit of K for rate order reaction? K is equals to mole per liter 1 minus n per second. So, you put n is equals to 0, it will become mole per liter per second. Okay. So, that is going to be the unit. Similarly, you can tell units for different things, right? Okay. This we have seen, this I have already taught you here. So, I'll just delete this slide, right? We have already done that. Okay. So, now let's see order, like how to calculate the order. Now, this is also a very famous thing to calculate the order of the reaction, right? A reaction, if first order is X and second order is Y. So, how do you calculate? How is the rate affected on increasing the rate of the reaction? So, a reaction first order in X, that means X raised to power 1. Second order in Y means this. So, this is K and this becomes the rate law equation. Now they are saying that in the first part, what we are saying, rate affected, that means new rate that you have, that I'll say as R dash, new rate affected on increasing the concentration of Y is increasing 3 times. So X is as it is, Y is 3Y raised to power 2. So it will become 9kx and this is Y square. That means it is becoming 9 times the older rate. So this is becoming 9 times, right? A part is 9 times. What about B part? How is the rate affected when concentration of both are doubled? Concentration of both are doubled. Okay, when the concentration of both are doubled, then what will happen? So here new rate will be K 2x and this will be 2y raised to square. This is 2, this is kx and this will be 2 into, this will be 4, because this will become 2 into 2, that is 4, this will become 2, to 4 into 2, 8, this will be y square, right? This becomes 8 of old rate, so answer will be, this will be increased 8 times, okay? And that's how you answer this question. On first it is increasing 9 times, on second it is increasing 8 times, okay? This is the first category of question they ask you. This is a very important category. Second category, if they ask you really good question from here, they will ask this question, okay? If they want to ask a really good question, they will ask this one, right? Okay? So, okay. Mechanism of hypothetical reaction. So this reaction is given to you. Whenever this kind of question is asked to you where 3 reactions are given, right, that means it's a complex reaction that they have given you. Now see what are the steps. Okay, I'll tell you what are the steps. See, it's quite simple. All you need to know is the steps that you will follow here. Right, everybody? Yes. Let's see what are the steps. Firstly, you will see the slowest step, that is your rate determining step, RDS. Here you will see rate is equals to rate constant, reactant, here it is x raised to power 1, this is y2 raised to power 1. Now always remember, in the rate law equation, order of the reaction, in the rate law expression, you can never write the intermediate. Intermediate, how you will identify which is the intermediate? Out of these two things, is there any molecule which is not there in the overall reaction? In the overall reaction, you have Y2, but you don't have X. So this becomes the intermediate. This becomes the intermediate, and how do you write it? R is equals to K. This is, you will have to replace this. You'll always, intermediate has to be replaced. You will replace it from here. Right, from here you will say Kc, equilibrium constant, is product by reactant. So product is xy, reactant is, product is not xy, product is x raised to power 2, reactant is x2. From there you will find the value of x. X will be equals to Kc multiplied by x2, under root and under root here. So you'll put this value, you'll put the value of x here, right? And you will get Kc half, this is x2 raised to power 1 by 2, this is y2 raised to power 1, okay? And this you can take as a new constant, this is x2 raised to power half, this is y2 raised to power 1. So you can say overall order of the reaction is half plus 1, that is 1.5. So answer will be 1 more. Usually students will write 1 plus 1, 2. No, it's 1.5 is the correct answer, and it's a very important question for your board exam, right? Okay, tell me everybody. Is that clear? Is that clear to all of you or not? Right? So that's how you write this particular question. That's how we solve this, and we got our answer here. Let's see some of the other questions here. That is, the order of the reaction can be fractional, but molecularity can never be fractional. But just see, what is order and what is molecularity? Order of the reaction is experimental quantity that we define experimentally, right? The slowest step will define the order of the reaction. Like from the rate law, from the slowest step, we will write the rate law expression, and that will define the order of the reaction. Okay, so we can't see this theoretically. Molecularity is actually a theoretical concept, that how many molecules are colliding, right? So order of the reaction can be fractional, molecularity can never be fraction. That is correct. See, order, we have already seen, it can be 1.5, it can be fractional, it can be negative, it can be positive, it can be 0. But molecularity can be 2, 3. It can never be 0. It can also not be 1. Number of molecules, half molecule will not collide, right? So it cannot be in fraction. Negative molecules cannot collide, right? 0 molecules cannot collide. Okay. Order of the reaction does not depend upon stoichiometric coefficient of the balanced chemical equation. Order of the reaction does not depend upon the stoichiometric equation of the balanced chemical equation. See, order of the reaction may or may not depend, right? So it's not that always it depends, right? So what you will say that order of the reaction does not depend upon the stoichiometry. That is also correct. This is also correct. So assertion and reasoning both are correct. Reason is the correct explanation of assertion. Now for that, what you will do, you will ask why. Why order of the reaction can be fractional, right? Because that does not depend upon how many molecules are colliding. That only depends on the experimental data. That does not depend upon how many molecules are colliding. So it does not depend upon the stoichiometric coefficients, right? So that is the reason. Right. Now, next one is the integrated rate law, and here I would advise you, I am just erasing the last part because I am here to tell you the important stuff. Okay. So this is not at all important for your CBSE board exam. Second order is not important for you, right? You can skip that. If you want to be safe, you can do, just remember the reaction. Just remember the formula, but zero order and first order are very important, right? For zero order reaction, the value of K, that is K is equals to initial concentration minus final by time, and also the value of first order reaction. For a first order reaction, what is the formula? K is equals to 2.303 by T log of initial by final. This first order reaction is most important. Just like I told you, Nernst equation is very important. Short question. This is very important. This is more important as compared to this one. First order question numericals are more important than zero order reaction, but zero order is also important. I am not saying zero order is not important, it is also important, but first order is more important as compared to zero order, right? So don't skip this one for your CBSE board exam. That is extremely important. Let's see how. Achha, one more thing that is important is the value of T half from here. Let me just see if we have written it anywhere, right? Okay. Oops. Wait a minute. I think I have not written it anywhere, right? I think so. Chalo. No issues. So always remember for first order reaction, right? For first order reaction, T half is equals to 0.693 divided by K. It is independent, right? Okay. And for zero order reaction, T half is directly proportional to initial concentration raised to power 1 minus n. If n is equals to 0, it is directly proportional to initial concentration, that is A by A naught by 2K, right? That is the formula here, A naught by 2K. These four formulas are important. This is most important. This is another most important. For zero order reaction, you should know the formula, otherwise rarely they will ask you that, right? But they can. First order reaction is most important. The first order reduction reaction takes place in 30 minutes for 75%. 75%, whenever things are given in percentage, you will take initial concentration as 100 and final concentration as 75 has been consumed. Okay. For this much decomposition means 75% it has already consumed. So 25% you are left with, that is 25 you are left with, right? Now you will just apply the formula, calculate T half they are asking. So you will have to calculate the value of K here. K is equals to 2.303 by T log of initial concentration is 100. This is 25. You will put all the values here. This is 30. Right, so K is equals to 2.303, this is by 30, this is log of 4, that is nothing but 2 square, that is nothing but that will become 2 into log of 2, right, that is nothing but 2.303 by 30, this is 2, this is log of 2 is nothing but that is 0.301, okay, that's how you calculate the value of log of K, right. That's how you calculate the value of log of K value. Now once you have the value of K, how do you find the value of this T half? T half is equals to 0.693 divided by K, right? Now this K will be in per minute because here time you have taken in minutes, so this time will be in minutes because it's a subjective question, it's not an objective question, so they have not mentioned anything that calculated in seconds or hours, so definitely you will write it in minutes, okay. That will be the answer, you calculate and you will have your answer here, right, okay. Another question from first order reaction is 40% complete. Now they are saying 40% in 80 minutes. That means when A naught is 100, 40% complete means 100 minus 40, that is, it is 60. Here T is given to be 80 minutes, right? They are asking you to calculate what time will be the reaction. Now one of the students has also asked, ma'am, what will be the answer when 90% reaction we want to complete. 90% means A naught will be 100, 80 will be 10. 100 minus 90, that is 10. Okay. So what you will do here, you will calculate the value of T from K from here. K is equals to 2.303. Time you will put here, log of initial is 100, final is 60. So you will solve this value here. You will calculate the value of K in per minute. You will calculate the value of K in per minute. You will put the value of K here. That is, time is equals to 2.303 by K, log of initial value is 100, final is 10, right? So you'll put the value of K, solving it in here, and you will get the answer of T 90%. Tell me guys, is that clear? Is that clear? And let's see how many likes you have given to the session till now. Let's see that, let's see that. Okay, so put in the values, calculate the value of K here, put it here, and you will get your answer here, right? Okay, this is another way. I have not done this way, I have done another way of solving this, right? So you will get confused, so that's why I am deleting this, right? Then next question is assertion based question that they can ask you from here. In a rate law, unlike the expression from equilibrium constant, the exponents for concentration do not necessarily match the stoichiometry. This is the same question. In the mechanism, not a balanced equation for the overall change. So basically they are saying in a rate law, unlike the expression for equilibrium constant, the exponents of the concentration, that means the powers, do not necessarily match the stoichiometry. That is correct. It can be, it cannot be. In the mechanism and not the balanced chemical equation for the overall change that governs the reaction rate. Yes, that is also true, Rate determining step will tell you the order. You will not get the order from the overall reaction, right? So that is also true. Now ask why here. Why equilibrium constant rate rate constant, sorry, when why equilibrium constant and order has different things. In equilibrium constant you raise to the power stoichiometry. Here it can or cannot be raised to the power stoichiometry. That means this is the correct explanation. So assertion, reasoning are correct and reason is the correct explanation. So A is the correct answer here. Right, everybody? Now this is a case based kind of question that you have. Yes, everybody? Now this is a case based category of question that you have. Let's see this. Yes, students? Case based. Read the passage given below and answer. Now what I told you, don't go through all these things. Beta, that is a wastage of time if you're reading the case based question, right? Overall paragraph, don't do that. Directly do the questions. Most probably questions will be answered without even looking at case base. But yes, go through the paragraph once, right? So first order reaction takes this much minutes for 50% completion. That means this is given to be T half. Time required for 30% completion. Beta, that's so easy, right? How? T half, from T half you can calculate the value of K. It is 0.693 by T half. You calculate the value of K, then we know that for 30% A naught is 100, AT is given to be 100 minus 30, that is 70. You solve it in this form, that is they are asking you the time, K T is equals to 2.303 by K, log of initial is 100, final is 70. You can solve it easily, log of 10 minus log of 7. K, you can solve it from here, put in the values and you will get your answer, okay? Then, calculate the overall order of the reaction which has the following rate expression. Order will be half plus this, so N will be half plus 3 by 2, that is 4 by 2, that is 2, that is also solved. What is the effect of temperature on the rate of the reaction? Now, this can be there in this overall, right? But we already know that temperature increases the rate of the reaction. So you can just write down rate of reaction increases with increase in temperature, and that's how you solve all the questions. See, I have not gone through the case based paragraph, right? That's why I'm telling you again and again, in case based questions, don't waste your time looking at the paragraphs. Don't do that, right? Okay. Now, last topic of physical chemistry. Right, after that we are going to take a 5 to 10 minutes break. We'll start with inorganic chemistry, then we are going to see organic chemistry, right? Okay, let's see this. Now we have Arrhenius equation. Now guys, whenever we talk about Arrhenius equation, it's a very important concept. The formula is K is equals to A e raised to power minus EA by RT. This also can be written as ln of K is equals to ln of A minus EA by RT. This also can be written as log of K is equals to log of A minus EA by 2.303 RT. So these are the formulas that you must remember, right? This one also and this one also, right? This one also. These are the formulas that you must remember, that is derived from the one formula, that is K is equals to A e raised to power minus EA by RT. Now when you solve it for two different rate constant at two different temperature, after solving you will get this as the formula. K2 by K1 is T1 minus T2 by T1 into T2. That is also very important. They can ask you numerical based question from this one. From here they ask you numerical based question, right? And from this one they ask you numerical based question. Okay? From this and this they can ask you graph based question. How graph based question? If you see ln of K is equals to ln of A minus EA by RT, you can see Y is equals to mx plus C. this is C, and if 1 by T is X here, minus EA by RT becomes the slope, right? And that is because slope is negative, that's why it is a declining graph, right? Okay. Next is the slope of the line. Now this question is very important based on Arrhenius equation. The slope of a line in the plot of concentration A versus time. So guys, if you see this here, this is log of K is equals to minus EA by 2.303 R, and this is 1 by T plus log of A, right? When you compare this, Y is equals to mx plus C. Now they are saying concentration versus time. Concentration versus time. Wait a minute. It's a concentration versus time. This is not this graph. I'm so sorry. This is not this. This is concentration versus time. Okay. So slope of a line in a plot of concentration versus time indicate. So because they have given K by 2.303, that means they are talking about log of 2.303 by T. This is log of initial by final. Okay? So if I say concentration versus time, concentration versus time, so we need to have that one, na? Okay, concentration versus time, that is rate only they are asking. Rate is concentration versus time, na? Rate is concentration versus time. So slope of the graph of concentration versus time, if you see this, concentration is equals to rate multiplied by time. So slope will be equals to rate, and rate is equals to, for different values it can have, है ना? Slope of the line indicates minus of K while the intercept represents R naught, right? So I think this question is actually not fully complete, okay, because they have not mentioned that what is the order of the reaction. They should have mentioned it there. So I'll just delete that because it is not properly mentioned whether it's zero order reaction or it's a first order reaction, because it is slope is rate, but now rate is dependent upon whether it's a zero order reaction. If you see this here, it depends upon whether it's a zero order reaction or it's a first order reaction. That will define the rate, okay, because rate is coming out to be concentration by time. So slope is actually rate. So rate will depend upon what is the order. So that is not given. So that's why clear answer is very difficult, right? Now let's see another question that is based on decomposition of A into product has a value of K as this. Energy of activation is this. At what temperature K would be this? Now if you see two values of K are given. This is, let's say this is a product has value of K as this. This is, let's say, K1. K2 you need to find out. Activation energy is given. Acha, K2 is also given. T2 they are asking you to find out. When T1 is given to be 283 Kelvin, right? So now what you need to do, you need to put this formula of log of K2 by K1, EA 2.03 R, T2 minus T1, T1 into T2. Wait a minute. Let me just correct it here. T2 hai na? This is what I was thinking. This is T2 minus T1. Okay? Not T1 minus T2. Okay? So now what you need to do, put in the value of K1, T1, EA, right? This is given in kilojoules, converted into joules by multiplying it with 10 raised to power 3, right? And put in all the values here, value of K, and you will get the answer of T2 after solving, right? Okay? Yes, everybody, tell me, is that clear? Is that clear to all of you or not? Beta, right now we are doing something else to focus there only, right? Okay, let's do that. Let's do that. Now, tell me if you want break of 5 or 10 minutes, right? How much amount of break do you need, right? So that after the break we can start with inorganic chemistry. Let's cover inorganic chemistry, right? Okay. In organic chemistry we have like total 5 topics here that I'm going to teach you. Lanthanoid contraction, then we are going to do lanthanoid contraction, then we are going to do KMnO4 K2Cr2O7, the preparation and properties of that, it is very important. Then when we are going to do properties of DNF block, some important properties I'll tell you, then VBT and CFT. Okay, tell me. Then break. Ma'am, whether you had dinner? No, I didn't have dinner. Yes. Beta, it will take time, right? Okay. Yes, Abhishek, I know, I told you, don't worry, I'll take extra sessions on Sunday, right? I'll take one shots and I'll complete that by November, right? What to do now? There are like so many other sessions I was taking, so that's why I was not getting slots only, right? So, yes, right? Tell me. I think let's have a dinner break. Even I didn't have dinner. So, let's have dinner break, right? By that time, after this, we'll start with, I'll give you 10 to 15 minutes of break. This is 10:04, so I'll see you all at 10:20 p.m. Okay? 10:20 p.m. I'll see you all and we'll finish this off. Right, everybody? Will finish this off, right? Okay. I believe that after this break, I'll not give you any break. After that, we'll finish entirely. Right? Okay. Chalo. And I'll see you all at 10:20 p.m. Right? So, where it is? Yes. So, here it is. I'm writing this at 10:20 p.m. class will be resumed. So I'll see you all at 10:20 p.m. right? Okay then. Okay. Yes. Okay, so everyone, class is resumed. Do let me know if I am clearly visible and audible to all of you. I hope so. You also had your dinner. And now let's start with the rest of the topics that we have. Okay, so now we'll be starting with lanthanoid contraction. Okay, so what exactly is lanthanoid contraction? If you talk about shielding effect of SPDNF, we know that shielding effect of S is maximum, then P, then D, then F, right? So what exactly we have? We have nucleus and we have electrons that are revolving around it, right? Nucleus will attract the electrons, but in between, if you have big orbitals, right, that will shield the outermost electron from the nucleus, then the attraction by the nucleus to that outermost electron will decrease, right? So better are the shielding effect, right? More shielding will be there, right? More shielding. See, let's say if here you have, this is the nucleus, these are the shielding orbitals and this is the electron. So if in between the orbitals they have very good shielding, if the shielding effect is very good, then the interaction of outermost electron and the nucleus will be very less, right? So the size will increase. So in lanthanoid contraction, the orbitals that we have is 4f orbitals, right? Sorry, 4f orbitals we have, 5f orbitals we have. So in lanthanoid contraction, we are talking about that before lanthanoids, you have 4f orbitals that are here, and f orbitals have very poor shielding effect. Because of their poor shielding effect, they are not able to protect the outermost electron from the nucleus. That's why the attraction is very high and the size, the nucleus will, the atom size will decrease, and that is called as contraction. That is why this is called as lanthanoid contraction. It is the abnormal decrease in atomic radii. Why? It is due to the elements from 57 to 71 atomic number from lanthanum to lutetium comes under the lanthanoid contraction. The lanthanoid have general electronic configuration, this one. Now that is the reason. The cause of lanthanoid contraction is the poor shielding effect of 4f orbital, due to which electrons of s orbital attract more towards the nucleus, due to which the size of the atom decreases, and that is called as lanthanoid contraction. Consequences are that decrease in atomic, because of the atomic the ionization enthalpy as well as electron negativity will increase, because size is inversely proportional to IE and electron negativity, right? The atomic radii, wait a minute guys, oh, what has happened, oh, what is this? Beta today to na, I think something or the other thing is happening here, right? I don't know what is the issue today. So I'll see, I'll have to hold the mic now, right? The mic is not working only. Okay, so just give me a second. After inorganic chemistry, I'll go and bring another mic, right? By that time, let's do this, right? Because of atomic radius is inversely proportional to the ionization enthalpy and this. They are hard to separate because of the strong attachment of outermost electron with the nucleus. It is hard to separate the lanthanides because the decrease is so much that they almost have same size, right? And another consequence is that 4D and 5D series will have same size. That's why hafnium and zirconium will have same size, and that question has been repeatedly asked to you. Now the question is, what kind of questions they can ask you? Firstly, for DNF block, I won't say this is important directly, you can answer this. Though I am giving you some important topics, but for DNF block you have to go through previous year questions, right? Past 10 years CBSE PYQs, do that for DNF block because they will be repeated only, and you will see same questions are repeated again and again. So ionic radii of TA and NB are same. The lanthanoid contraction cancels almost exactly normal size increase and decrease a group of transition elements. So basically 4D and 5D series, they have the same. 4D and 5D series, they have the same, that is the consequence. So that is why TA and NB have same. So lanthanoid contraction almost exactly normal size increase on decreasing a group of transition elements. So that is the reason. Assertion and reasoning both are correct, and reason is the correct explanation. Now another topic is KMnO4. From here you have to go through the preparation and oxidizing agent, oxidizing power of KMnO4 and K2Cr2O7. So they are prepared from pyrolusite ore, as it is the question is asked from here. Pyrolusite ore, that is MnO2, they are prepared from. MnO2 is this converted to K2MnO4, that is your manganate ion. Now to convert manganate ion to permanganate ion, you have two methods. First is electrochemical oxidation. You convert manganate to permanganate. Manganate is green color, permanganate is purple color. Or you, in the manganate ion, in acidic medium, manganate ion is converted to permanganate ion, right? So in acidic medium, manganate ion will exist, but in basic medium, manganate ion will exist, okay? Dark purple crystal, sparingly soluble in water, strong oxidizing agent it is. That is why permanganate ion in the acidic medium, it is converted to Mn2 positive, right? It oxidizes I negative to I2, F2 positive to F2, 3. That means oxidation will take place here, right? All of these are important. All of these are important, right? Most important is this one, I negative to I2, because in acidic medium, MnO4 negative is converted to Mn2 positive, and it oxidizes I negative to I2. But in alkaline or faintly alkaline medium, permanganate ion is converted to MnO2. This is also very important. These two things are very important. And here, I negative is converted to iodate ion. This is also very, very, very important. Right? Here, I negative is converted to I2. Very important. Right? Okay, this is very important thing that you must remember. Okay, yes everybody, tell me. Now, next is potassium dichromate. You should remember the ore, that is chromite ore, from which it is formed. Firstly, from the chromite ore is converted to sodium chromate, right? Then sodium chromate is converted to sodium dichromate on addition of acid. Then sodium dichromate is converted to potassium dichromate, right? Now if you talk about that, the properties are, they are orange colored crystals, and whenever you have, it's very important, in acidic aqueous medium, dichromate and chromate ion exist as follows. In alkaline medium, equilibrium shifts in the forward direction. That means in the alkaline medium, chromate ion will exist. In the acidic medium, dichromate ion will exist. This will exist in alkaline medium. Very important that acidic to alkaline, in acidic medium, dichromate will exist. In alkaline medium, chromate ion will exist. Okay? In alkaline, this is very, very, very important, right? So, I am giving you directly some of the important things. Now, Because we know that only in acidic medium this exists, so we are writing that in acidic medium, in basic medium, it will not exist only. So in acidic medium, dichromate ion is converted to Cr3 positive. Very important that how it itself is behaving as an oxidizing agent, itself it is converted to Cr3 positive. Now oxidation is same, right? I negative to I2, not to iodate ion. This is not at all converted to iodate ion. Okay, that you must know. Right? Now let's see some of the properties of DNF block. Okay, because mixed questions are asked from here. Let's see. First thing is, guys, you should know the exceptional electronic configuration that I have written here. I'll just tell you what are the most important. Firstly, chromium is very important, copper is very important, then Ru is important, Rh is important, Pt is quite important, lanthanum is important, Pd is important, right? Ag is important. So these are some of the very important, and Nb is also important. This also you can do, right? But this I would say is less important. The one that I have marked with 2 stars are more important. These you can skip also, right? AC, Rg you can skip also, right? These are most important. The one that I have mentioned with 4 stars, right? The one that I have mentioned with 4 stars, they are most important, right? Okay, then 3 star are less important than that, right? Then you have, yes, this is the 1 star, this is 2 stars, 3 stars. NB is important, this has been asked, right? So these are the electronic configurations that you must know from the lanthanoids, right? Then guys, let's talk about some of the properties here. Let's talk about like I'm talking about very specific, otherwise this chapter is very lengthy, okay? So we can't complete, I'm only talking about important properties here. I'm not talking about full chapter here. I'm only talking about some of the repetitive properties, right? First is you should know about melting point, that what are the maximum in any row, the melting point of these firstly rise to maximum to D5 configuration, except for manganese and Tc, and fall regularly as the atomic number decreases. So what is there? So firstly it will increase to the half-filled configuration, but in terms of Tc and manganese, it is exceptionally it will decrease, right? Here tungsten you have. So one thing they can ask you, maximum melting point in case of 3D series of chromium, then you have molybdenum, then you have tungsten. Okay, that they can ask you, and this they can ask you that after molybdenum exceptional decrease is there, after chromium exceptional decrease is there. This is important for you. Then guys, from the atomic radius, what you should remember, that 4D and 5D series have same, almost same. This is the consequence of lanthanoid contraction, right? That this is 3D, this is 4D, and this is 5D. 4D and 5D has almost same atomic radius because of the lanthanoid contraction. Okay, and how it works, firstly it will decrease, then it will become constant. So you should know the order of 3D atomic radius, right? This is important. 3D it is important that firstly it will decrease, it will decrease, it will decrease. Then iron, cobalt and nickel, they will become almost same, then it will again rise. Okay, that is an important part, right? Then guys, we have stability of higher oxidation states. Now you will always see that higher oxidation states are more stable, right? What you will see that higher oxidation states are stable in case of chromium and manganese, right? As you go as you move towards 21 or you go atomic number increases, higher oxidation state will decrease, right? Similarly for oxides also you will see manganese exists in +7, right? Rest of them does not exist in +7, right? So higher oxidation states are shown by manganese or chromium, right? Okay. Chalo, now let's see, among the following, the bivalent ion of the first transition series shows maximum magnetic moment. Now I'll tell you from the questions how do you answer. Now bacha, we are going to see some of the questions, we are going to see from the questions how to answer, because DNF block is more of, you do more questions and more understanding will be there. Right, so some sample questions I have picked up for you. First is based on magnetic moment. So always remember, n is equals to unpaired electrons. So mu is equals to under root n plus 2. Bohr magneton. Now you should always remember, if n is 1, mu is, I'll just draw the, if n is 1, 2, 3, 4, 5, corresponding to that, this will be 1.7, 2.8, 3.8, 4.9, 5.9. That will be the magnetic moment corresponding to that. You don't even need to calculate, but you should know the formula. Now you should know the configurations, right? You'll be able to answer a lot of questions from DNF block, right? So that's why I'm telling you that there are like, I can't teach you theory here, right? Theory you can do only in detailed portion, but there are some specific things that are very, very important, right, that you should know. And for that you should know how to write the electronic configurations. Now let's see that how to write the electronic configuration, because that is a very, very important part. Okay, so this is 21, 22, 23, 24, wait a minute, this is 22, this is 23, this is 24, 25, 26, 27, 28, 29 and 30. Now how do you write it? Simple, you write 4s everywhere, 4s, 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 4s. I'll just copy, no, I can't copy paste this here. 4s, 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 4s and 4s. Now here you write 3D, 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 3D. This is very important. You must know about the electronic configuration of 3D series. Otherwise, coordination chemistry and DNF block both are out of your hands, right? So here what do you write? This is exactly 2, 1, 2, 2, 2, 3. This is 2, 4. This is 2, 5, 2, 6, 2, 7, 27, 28, 29. Now 30 you can't write 3 here, so that's why you're writing 2, 10. Okay. Now this one is an exception, so you will cross this one, and chromium is an exception. Because in this case you will have 4s1 3d5 because of half filled, and in this case you will have 4s1 and 3d10, right? This is how you should learn the electronic configurations of DNF block, right? They should be on your tips, because based on that, if you know the electronic configuration easily, you can answer anything. Now if you see this here, cobalt, now we know that cobalt is 27, it is 4s2, 3d7. You take out 2 electrons. Always electrons are taken firstly from 4s. So you take out 2 electrons, this will become 3d7. 1, 2, 3, 4, 5, 6, 7. So you are left with 3 unpaired electrons. That means here it will be 3.8. Right? This will be 3.8. You have 3 unpaired electrons. In case of nickel, you have 28, so it is 4s2 3d8. You take out 2 electrons, it will become 3d8. When you fill the electrons in 5 orbitals, right? So it will be 1, 2, 3, 4, 5, 6, 7, 8. You have 2 electrons, that is, this is 2.8. This manganese is obviously going to show the maximum, because manganese is 3d5. Okay, manganese 2 positive is 3d5. So you have 5 unpaired electron, that is 5.9. This is going to show the maximum. Fe will not be so. So answer will be manganese is the correct answer here. Right? Then a question that has been asked in CBSE 2023, that is based on copper. Copper, if a non-transition element, copper is a non-transition element, copper has completely filled d orbitals. Zinc, cadmium, mercury, they are non-transitional, other are not non-transitional. So this is false, right? Okay. Then you have copper has completely filled d orbital in its ground state. So copper is 4s1 3d10. In its ground state, it has completely filled d orbitals. That is absolutely correct, right? But in the excited state, it does not have. So that is why we'll say A is false and R is true, right? Assertion is false, but the reason is correct here. Now you need to focus on these questions because from DNF block directly, they don't ask you as such one question and one numerical will be there. Mostly in DNF block, you will see in board examination, the questions will be in parts, A, B, C parts. You will see, pick out the PYQs and you will see it in that way, right? So I am giving you some sample questions here, right? I am teaching directly the questions because you have to go through the questions to understand the concept, right? So first is account for the following. This is E0 value of manganese 3 positive to 2 positive couple is much more positive than this. Now you will see a lot of questions based on E0 values, right? So first is E0 value of manganese 3 positive to 2 positive is this. So basically manganese 3 positive, but firstly tell me, is this reduction or oxidation? Here oxidation number is decreasing, so this is reduction, right? So for this reduction to take place, here we are saying that manganese 3 positive should be converted to 2 positive. That means it is going to gain 1 electron and it is going to get converted to this. Manganese 3 positive is what? Manganese 3 positive is 3d4. This is becoming 3d5. So easily it can gain 1 electron. It wants to gain 1 electron. So its reduction potential will be very high, right? Is much more positive. Reduction potential will be very high. I want to gain the electron, right? Then this will be Cr3 positive to Cr2 positive. Now if you see this here, chromium is 4s1 3d5. Right? So here Cr3 positive means 1, 2, 3. So it will be 3d3 here. This is Cr2 positive is 3d4. But here what you will see, this you will see in CFT, that this is 1, 2, 3, 1, 2. Here Cr3 positive is this kind of situation, right? So in T2G you will see a very symmetrical configuration. Here it is symmetrical. Here this one is more stable. Here this one is more stable. That's why chromium 3 positive you will see is very stable ion. This one is not stable. So this conversion is difficult. This conversion is difficult. So its reduction potential will be very low. It does not want. So always and always whenever they ask this has more value, this has less value, but you just have to write down the electronic configuration. That's it. You just have to write down the electronic configuration. When you write down the electronic configuration, if it is going to a stable state, E0 value will be very positive. If it is going into an unstable state, E0 value will not be positive. It will be less positive or it will be negative here. Okay? Understood this? Understood this, everybody? So always you will see a lot of pairs here. You will see different, pick out the PYQs. You will see almost every year, like maybe in a gap of 1 year, you will see a question that is telling you about E0 value. So this particular question is very, very important, right? Next is scandium 3 positive is colorless. Now next question is based on colorless and colors. Right, this is also one of the important question that is again based on electronic configuration. That's why I showed you that electronic configuration is very important for your 3D, for your DNF block. So always remember for a colorless, you should have D0 or D10 configuration. Then it will be colorless. Now if you see scandium, scandium is nothing but it is suctive. Suctive means 4s2 3d1. So scandium 3 positive is nothing but 3d0. Okay. Titanium 3 positive. Titanium is 4s2 3d2. Titanium 3 positive is 3d1. Okay. Titanium 3 positive is 3d1. So now because titanium 3 positive is 3d1, that is why this is colored. Titanium 3 positive is colored, this is colorless. Right, that is done. Third is actinoids show wide range of oxidation state. Third is that actinoids show wide range of oxidation states. Reason being they have actinoid contraction. Their size is quite similar because of 5F poor shielding effect. Just like lanthanoid contraction, you have actinoid contraction, and that is the reason they have very similar sizes, right? Write the chemical equation for the preparation of KMnO4 from MnO2. This is, so beta, they can ask you any kind of question based on preparation or the properties. That's why I told you that topic is quite important. Right? Okay? Because that is a particular set of reactions that you have. You don't have, it's not like they can change the reactions. You have particular set of reactions from where directly they ask you the questions, right? Now see, this question is CBSE 2016. Mn shows highest oxidation state +7, which with oxygen, but fluorine shows highest oxidation state of +4. Why? This is exactly a line of your NCERT, that oxygen, with oxygen it forms multiple bonds, that's why it can show higher oxidation state with oxygen. So manganese form p pi d pi bond with oxygen by utilizing 2p orbital of oxygen and 3d orbital of manganese. It is forming pi bonds, it is forming multiple bonds, due to which it shows highest oxidation state of +7 with oxygen, not with fluorine. This is exactly a line from your NCERT, right? But keeping in mind that you guys are CBSE, like if you're stuck to that, ma'am, I am just preparing for board examinations, I am not preparing for JEE, ma'am, right? In that case, you don't have to go through NCERT each line, go through the previous year questions of DNF block. That will be more useful, right? Because that repeated questions are asked, right? But if you're preparing for JEE also, you're preparing for other exams also, you also want to get a good college, then guys, please go and study DNF block theory from NCERT. That will be more beneficial, right? Okay. Now let's see this case-based questions. So what I told you for case-based question, never go through the paragraph. You don't have to read out the paragraph. It's a waste of time. Firstly, see the question, then see whether you know the questions, and then see the paragraph, right? So here it is. Which of the 3D series transition element exhibits largest number of oxidation state and why? Which will exhibit largest number of oxidation state? Manganese, right? Manganese shows maximum oxidation state, right? Because it has 5 unpaired electrons, right? Okay, and they are of close energy, that is why it shows maximum oxidation states from +2 to +7. A transition metal exhibits highest oxidation state in oxides and fluoride. Repeated question. Can you see? That's how the questions are repeated, right? So this we know that with oxygen it forms multiple bonds. How would you account for increasing oxidizing power in the series? How, or they have asked you, MnO is basic, whereas this is an option. Now in CBSE they also give you a lot of options, so you have to know both the answers. How would you account for the increasing oxidizing power? Because of their oxidation state. See, now this is due to the increasing stability of lower species to which they are reduced, right? Okay, so that is the reason. To lower species, for example, this is x minus 8 is equals to minus 7. This is Mn plus 7. This is 2x minus 14 is equals to minus 2. This will be 12. This will be 6. Chromium plus 6. This is vanadium x minus 4 is plus 5. So it is vanadium plus 5. So oxidation state is higher here. That's why oxidizing power will be higher. Then MnO is basic, where Mn2O7 is acidic in nature. Give reason. More the oxidation number, more will be the acidity, right? So higher oxidation state will be acidic. So oxidation state is directly proportional to the acidic character. So here you can see, here x is equals to plus 2, here x is equals to plus 7. Why? 2x is equals to minus 14, it will be plus 7. Right? So more is the oxidation state, higher will be the value of the, higher will be the acidic nature. Right? That is also a very important rule. Okay. Now some specific things we have again. Now this is specific. Like in properties of DNF block, the questions are quite distributed. So you have to go through a lot of questions. But in VBT and CFT, you just need to know some of the important concepts and you will be able to answer any question based on that. Right? That is the benefit of CFT and VBT. So let's complete CFT and VBT now. Let's do that, right? So guys, in VBT, I'll directly tell you how to answer the questions. First thing is, you should know that in VBT, we have two kind of things. See, basically what in CBSE level, till CBSE level, you will have coordination number 4 or coordination number 6. Coordination number 4 will give you either DSP2 or SP3, right? This means it is square planar, this means it is square planar, and this means it is tetrahedral. It is tetrahedral. Coordination number 6 will give you either sp3d2 or d2sp3. This will be outer octahedral, right? And this will be inner octahedral. Inner octahedral, right? That is going to be inner octahedral. Right? So these are the things that you will have. Now let's see that, and you know here, this so I have already told you that this will be the magnetic moment, right? Acha, this also I have already told you, this you don't need to go through. Okay, I will directly tell you. With the help of questions, we will know that how to solve this. Okay, these are some of the exceptions that I'll talk about, right? Firstly, let's go through the questions, okay? With the help of questions, I'll tell you how to solve. So here a question is given and they are saying that this is D2sp3. How do you find it? Firstly, whatever is the compound, coordination compound that is given to you, you will always and always firstly calculate the oxidation number. So it is x minus 6 is equals to minus 3, x is equals to plus 3. That is the coordination number. That is the oxidation number. So iron, we know that it is 4s2 3d6. Again, electronic configuration has a usage. That's why I told you electronic configuration is important. Fe3 positive is 4s0 3d5. Now you have 5 electrons. Now this is 3d. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 5 boxes in 3D. Now guys, see one thing. You have 5 boxes in 3D. You will have 5 electrons here. Now what you need to see that whether Cn is a strong field ligand or a weak field ligand. That we will know from spectrochemical series. That also I will tell you. Till now just remember that Cn is a strong field ligand. It will cause pairing. So it will be 1, 2, 3, 4, 5. 2 orbitals are left behind. So it will be D2sp3. Coordination number 6. Coordination number 6 means either it can be sp3d2 or d2sp3. So it is coming out to be d2sp3. That is correct here. And shows magnetic moment corresponding to 2 unpaired electron. That is also unpaired electron is 1. This is false. Unpaired electron is 1. Number of unpaired electron is 1. So we can say assertion is correct, reason is wrong statement. So we can say C is the correct answer here, right? Next is another kind of question that they can ask is another C. This ion is given to you. Now ammonia is also strong, right? So how do you do that? Again, you firstly find the oxidation state. X plus 0 because ammonia is a neutral ligand. These basics you should definitely know. Basic I can't teach you in just a very small session, right? In a revision session I can't teach you the basics, what is oxidation state, what is coordination, that you have to see the detailed lecture, right? So I'm telling you the important topics here. So firstly you will calculate the oxidation number. Once you calculate, then you will find the electronic configuration of chromium is 4s1 3d5, right? Now chromium 3 positive is always take out the electron from 4s first, 1 from here, 2 from here, you will have 3d3. Now see what you will have. You will have this D 1 2 3 4 5. Now students see, you will have 3 1. Now it's a strong field ligand, so it will be like this. Wait a minute, 3d3 na? No doubt it's a strong field ligand, even if it is not paired, because what way, either we can have sp3d2 or we can have d2sp3. So you can have 1 2 3, even then you will have d2sp3 here. Even then you will have d2sp3. So the hybridization is going to be d2sp3, that is the shape is going to be octahedral here, right? And that's how you will have number of unpaired electron is n is equal to 3. So mu is equals to 3.9, and that is going to be your correct answer here. Now guys, why this chart I have given you, because you know, how ma'am do I find that, ma'am, okay, oxidation number is easy, ma'am, that we can calculate. Ma'am, that is also easy. Electronic configuration writing, that is also easy. But ma'am, who will tell me whether there will be pairing or no pairing? So that is the confusing part here. That's why firstly though you should know about this particular thing, that is your spectrochemical series that I have written in terms of a question only, right? So this spectrochemical series you should know. Like CO is a very strong field ligand, CN is strong field, then ammonia is sometimes strong field, sometimes weak field, water is weak field ligand, right? Okay, these are some of the important ligands. Halogens are weak field ligands, that you should know. Then you should know about this exceptional, wait a minute. Then you should know about this chart that is for exceptions, right? This chart is totally dedicated to the exceptional case, right? So this chart is totally connected to the exceptional. Like CO3 positive is bonded with water and oxalate, then ligand act as strong field ligand. Water and oxalate is not a strong field ligand, but with CO3 positive it will act as a strong. These are the exceptions, okay? Cu2 positive bonded with water, then ligand Cu2 positive also will make water as strong field. This is not important for you, but Ni4 positive, this one is important for board examination. This one and this one. This one you can skip for board exam. This one is also important, that Fe and this bonded with NH3, then the ligand act as weak field ligand, right? 3D series element in +2 oxidation state form outer octahedral complexes up to NH3 in the spectrochemical series. That means they don't cause pairing up to ammonia, right? And PT, PD, AU with coordination number 4 will prefer DsP2 hybridization, that is square. These are some of the important points that you should know. So I have directly written these exceptional cases because exceptions are quite difficult for students to remember, right? Then the next part is, guys, we have CFT, right? So now in case of CFT, crystal field theory, 2 cases you have. Okay, first is octahedral Then there is tetrahedral. Square planar we don't have in our syllabus. We have tetrahedral. So I'll directly tell you what you need to remember here. See what exactly happens in both the cases. The degeneracy will break. Degeneracy means same energy will break. Firstly, they will all have same energy. Then when the ligand is approaching, their energy will increase and then their energy will split into two parts. So in case of octahedral, the splitting is like this. You have T2G, this is EG, right? This is EG. But in case of tetrahedral, you have E and this is T2. Right? This is how the splitting works. In case of octahedral, you have 3 and 2. In case of tetrahedral, you have 2 and then 3. Right? Okay? Reason being, because octahedral complexes are between the axes and these two are between the axes. So, octahedral complexes are along the axis, and that's why dz square and dx square minus y square, which are along the axis, their energy will increase, and that's why T2G and then EG. From the barycenter, they will have the value 3 by 5 and here they will have minus 2 by 5. Okay? Then opposite will be for tetrahedral. Here you have 2, here you have 3. Here from the barycenter it's plus 2 by 5. Here it is minus 3 by 5. Right? Now let's see one more thing here. When you have strong field ligand, now what kind of questions they ask you? For example, you have a strong field ligand. Now always remember one thing, that I'm writing it here, right? Always remember one thing about a strong field ligand. About a strong field ligand, always remember one thing. I'll just tell you here. Strong field ligand will always cause pairing. Because of pairing, you will have low spin complexes here, right? And in the strong field ligand, the pairing energy, CFSC, will be very less. CFSC will be less. Wait a minute. In a strong field ligand, the pairing it is causing, wait a minute, if it is causing a pairing, if it is causing, the gap is very high, sorry. The gap is very large. CFSC is very high. Gap is very large. Between these two, the gap is large in strong field ligand, that's why it will cause pairing. If you add first electron, second electron will fill here, third electron, now fourth electron has an option whether it will go here or it will go here. If the gap is very large, it will go here. If the gap is very small, it will go here. Right? So that's how it will work. So CFSC is very high, and in this case, pairing energy will be less than delta. And opposite will be there. In weak field ligand, you will have no pairing, high spin, CFSC is less, and pairing energy is greater than delta O. Okay? That is the important part. Now let's see, this is based on spectrochemical series. Directly from the spectrochemical series, they can ask you the spectrochemical series, they can ask you MCQ based on spectrochemical series, right? From here, just like this, from the spectrochemical series, you will tell the order, anything they can ask you. So this series should be on your tips as it is, right? Okay, you can learn a mnemonic to answer this. Now let's see, okay, wait a minute, no, this will not talk about, this is not under our important topics, right? So we'll not talk about that. That is important. See, IUPAC naming is important, right? But I have not covered it here. But IUPAC naming, I would say most important is CFT and VBT. Then priority decrement will be, if you ask me, ma'am, what are the most important 60 topics, what are the most important 50 topics, then I will include IUPAC naming. But we were talking about most important 22 topics only, I told you. So out in that topics you don't have IUPAC naming. But IUPAC naming question can be asked. If Werner's theory, question can be asked. ऐसे तो question can be asked from anywhere, right? Okay, so that you have to take care. Right, everybody? Ma'am, please take rest. Yes, I'll take rest. So before taking a break, now I'll just need to, have another mic. So after this, we'll finish off organic chemistry, right? Which will take me hardly 1 hour to finish that, right? Not that much time, right? So we'll finish off organic chemistry now. But before that, let me remind you that our test series is at off, and this is 80% discount that we have right now. That is at 999 that you have it. So click in the link in the description. You have a very good discount on these test series, that is Eclavia test series. Click on the link in the description box and you can purchase the test series, right? Okay. Yes. So before taking the break, I want to cover SN1 and SN2 reactions and elimination reactions, right? Okay. Yes, everybody, ready, do let me know. Let's cover SN1 and SN2 reactions, okay? So directly I'll tell you a very basic thing. In a simple manner, I'll teach you. SN1, 1 means 2 step, 2 means 1 step. Remember that. 2 step means firstly you will form a carbocation, then you will form the product. 1 step means directly you will form the product, okay? So firstly, let's talk about SN1 reaction, which is a 2-step reaction. In a 2-step reaction, what you have is, you firstly have the formation of carbocation. So firstly, for example, this Br will be eliminated. You will have the formation of a carbocation. Then if possible, you will rearrange that carbocation. Rearrangement you have studied in class 11th. Because this is a 2-degree carbocation, this will be converted to a 3-degree carbocation, right? A hydride shift will be there. And this particular carbocation will be converted to this hydride will shift here, and you will have a 3-degree carbocation. 3-degree carbocation is more stable. This you have studied in GOC in class 11th. Okay. So 3-degree carbo, always it's like this, 3 degree, then 2 degree, then you have 1 degree, right? 3-degree carbocation is more stable. This they have shown you hyperconjugating structure. I don't know if you remember this or not from class 11. So assuming that you don't remember this, right? I'm directly telling that 3-degree will be more stable. That's why now on that 3-degree, you will have the attachment of the nucleophile, that is OC2, CH2CH3, and that will attack here and you will have the product. So that means SN1 reaction, you will have the formation of carbocation and rearrangement. The slowest step is this one, that is rate determining step, where you don't have any nucleophile attack. That is the reason in SN1 rate expression only has substrate, there is no nucleophile, because it is dependent upon only substrate. That's why it is SN1, unimolecular, right? Okay, molecularity and order is 1. Partial racemization. Now what exactly happens? Because it forms a carbocation, it can attack from this side as well, it can attack from this side as well. This is the carbocation that you have. Now it can attack, nucleophile can attack from this side as well, this side as well, right? That is the reason 50% retention and 50% inversion will be there, that is racemization. In SN2 mechanism, things are different. Directly nucleophile will attack here, right? Array, wait a minute. Acha. Yes. In SN2 mechanism, what exactly happens? Directly you have the, wait a minute, how do I write it? I think I have Deleted that page, chalo, theek hai. Now exactly what will happen here, firstly Br negative will leave and from the opposite direction you will have the attack of nucleophile. From this side nucleophile cannot attack. From the same side nucleophile cannot attack. Ma'am, why? Ma'am, why the nucleophile cannot attack from the same side? Because it is taking place in one step. In the same step leaving group is leaving. In the same step nucleophile is attacking. And that's how you will have the formation of this kind of product. Right? This is H, this is CH3 and this is D. So inversion product is formed. So from that side where leaving group is leaving, from the same side nucleophile cannot attack because leaving group is already there. Right? There is no carbocation that is formed in SN2. That is the reason you have inversion of configuration here. Overall order is 2 because in the rate determining step, you have nucleophilic attack as well. Right? So that's why it depends upon both the substrate and the nucleophile. Right? That is SN2 mechanism. Now remember one thing, that SN1 mechanism, it will be more in 3D, then 2D, then 1 degree. Why? Because carbocation stability we need. Where the carbocation is stable, it will take place SN1. In case of SN2, if this particular alkyl group is highly sterically hindered, then the attack of nucleophile will be difficult. So we need less steric hindrance. Less steric hindrance. So 1 degree, then 2 degree, then 3 degree. That is the order. Right? Okay? And here in case of SN1, you will have a weak nucleophile. In case of SN2, in case of SN1, you need a weak nucleophile. Right? That is not directly attacking. So in case this, you have a weak nucleophile. Like a neutral nucleophile you will have. Right? But in case of SN2, you need a strong nucleophile, like a charged nucleophile you need here, right? Only then SN2 reaction can take place, right? Let's see some questions based on that. So it is, which of the following undergoes nucleophilic substitution reaction exclusively by SN1 mechanism? SN1 means formation of carbocation. You need a stable carbocation. Benzyl chloride will form this kind of carbocation that is quite stable. Chlorobenzene will form this kind of carbocation which is not at all stable. Isopropyl chloride will form this kind of carbocation which is also stable. This isopropyl chloride which is also stable, but it is not stable as compared to that. Ethyl chloride is also like not unstable also, but it's also not that stable, right? So benzyl chloride, because of the resonance that it shows, it will be showing SN1 mechanism here, right? Another question related to this. From SN1, SN2, MCQ based question, assertion reasoning based question, subjective, anything they can ask you. It's a very important topic from haloalkanes and haloarenes. SN2 substitution reaction, this is RBR, this is Cl, you have DMF. Now remember that DMF is a aprotic solvent. So it will give rise to SN2 mechanism, right? So what you will have is SN2 mechanism for a polar aprotic, right? For a polar aprotic solvents. Polar protic, if the one that are giving you protons, like you have alcohols, that gives you water, that gives you proton, they give SN1 mechanism. But if you have polar aprotic, you have DMF, DMSO, I'm giving you some examples, DMF, DMSO, if you see it there, then you will be able to understand that this will definitely give SN2. DMF or DMSO are quite famous, right? So they will give you SN2, that means You need less steric hindrance. Less steric hindrance is there in this particular part, so answer will be A is the correct answer here. Right? That's how you will answer. Now that was MCQ based question from SN1, SN2. Now let's talk about the questions. Okay. Now let's talk about those kind of questions which are like, subjective questions that they have asked. Achha, this is not subjective, this is also MCQ. Yeah. This is your PYQ based on SN1, SN2. They have asked racemization occurs in SN1 reaction, SN2 reaction, neither SN1 nor SN2. Simple question. Racemization occur in SN1 reaction, that is carbocation formation, right? Then assertion reasoning question based on SN1, SN2, that is hydrolysis of 2-bromooctane proceeds via inversion of configuration. This reaction proceeds through formation of carbocation to give plus octane 2-ol as a product. Firstly, what is bromo? Bromooctane 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. 2-bromo means here. You need octane 2-ol means this one will be formed. Now, this reaction, it can form a stable carbocation. So, inversion of configuration or this, how it will take place, right? So, it depends upon so many things, but we know that here it forms a 2-degree carbocation, which is not a very stable carbocation, which is also not unstable. But here one thing you are definitely sure of, that this CH3 will not cause that much steric hindrance. So this side is not sterically hindered. So SN2 attack can take place. So that means inversion of configuration will take place, right? Basically they are asking that whether it's SN2 reaction, this is SN2, this is SN1. Which reaction is correct? So both the statement cannot be correct, only one will be correct. So hydrolysis of alkyl halide follows inversion of configuration. It's an SN2 mechanism because of the less sterically hindered product. Okay? Here this particular, if let's say bromine is over here, then it will follow SN1 mechanism because both are sterically hindered portions. Because it is on the second carbon, so it is less sterically hindered. That is the reason SN2 mechanism it can easily follow, and answer will be A is true, R is false is the correct answer here. Let's see next question. In each of the following pairs of compound, identify compound which will undergo SN1 reaction. Very important topic, huh? This is SN1, which will undergo SN1. The one which is forming a stable carbocation. Which is forming a stable carbocation out of these two? This is positive 3 degree. This is 2 degree. So obviously this one is more stable. So this one will undergo SN1. Out of this one will undergo SN1 because a benzyl carbocation is formed, which will show resonance. Here you will have phenyl carbocation, which is very unstable. This is not at all stable. Phenyl carbocation is very unstable, so that will not be formed. So we will see that is not correct. This one is correct. So answer will be this one. Okay, right everybody? So here this one and here benzyl. Okay, then we have a case based question based on your SN1 and SN2 reactions. So firstly tell me, do we need to go through the paragraph? Tell me everybody. I have solved all the case based questions in front of you. I have never even seen the paragraph. Yes, tell me, do we need to read the paragraph first or the questions first? Yes, tell me guys. Azad, Darshan, Nisha, tell me. Nishal, Shruti, Biswajit, Darshan, Tarun, Vijay. Yes, students, do we need to? No need. Yes, no ma'am. Very good. We don't need to study that. We don't need to waste our time in that. If we need, we will go through that. Firstly, we need to see what questions they are asking. Why racemization occur in SN1? Because attack can occur from both sides. Retention, inversion, both is there. Why is ethanol less polar than water? Because in water you have two hydrogens, highly electronegative, electropositive. In case of ethanol, C2H5, which is a hydrophobic part, this is a hydrophobic part, that's why it has less polarity, right? Alkyl chain always will be less polar, right? Which one of the following in each pair is more reactive towards SN2? SN2 guys, is this carbocation is formed or not? Or is this sterically hindered product? Which will be in SN2? Is this carbocation or sterically hindered? Yes, I am waiting for your, ma'am, low, please keep it stable. Acha, voice is changing her. Oops. Beta, what to do? Hana, just now, you know what has happened. Today, though, something are happening with my studio. My mic now in this situation. So I'll go, I'll just go and pick up another mic, right? Just give me a second. Right? Okay, I'll see if I can somehow, you know, connect it, but I'm not able to do that. Okay, yes everybody. So sterically hindered product is formed here, right? Less sterically hindered product, and if we see both are same, now I have to see which is a good leaving group. Which is a good leaving group? Chlorine or like iodine? Which is a good leaving group? Iodine is a good leaving group, right, as compared to chlorine. Because this bond is larger, so it is Ci bond is easy to break, right? Out of these two, which is sterically hindered, this is less sterically hindered, so this one will show SN2. So answer will be here, it is this one, because I negative is a better leaving group, and here it will be this one, which is more reactive as it is less sterically hindered. Right? Okay. Now let's talk about elimination reactions. Okay. Let's talk about elimination reaction, right? So in case of elimination reactions, guys, what we have, I'll just, most of the students, CBSE board students, are very rarely seen, they know about elimination reaction. So that's why this part you should know, so that you can differentiate things. So elimination means the elimination of things. So it can occur in three ways: alpha elimination, beta elimination, or 1,3 or 1n elimination. Alpha elimination is 1,1 elimination. That means the leaving group and the hydrogen is leaving from the same carbon. When the leaving group and the hydrogen are leaving from the same, in the presence of base, chloroform or bromoform can dehydrohydrogenation to form a carbene. This is a very important step of Reamer-Teamer reaction and carbylamine reaction, which leads you to the formation of dichlorocarbene, right? So here chlorine and hydrogen will leave from the same part, right? Then again chlorine will leave and you will have the formation of dichlorocarbene. Now, if leaving group and hydrogen is leaving from the adjacent position, that is called as beta elimination. That means hydrogen is leaving from the beta side of the leaving group. So where leaving group is leaving, that is alpha side. Where you have hydrogen, that is the beta side. So it is leaving from the beta side, that is called beta elimination, right? And when elimination is from maybe third carbon, here this is alpha, this is beta, and this is gamma, right? From the third atom, you have the elimination of hydrogen. So here alpha leaving group is leaving and hydrogen is leaving from the third position. That is called as gamma elimination or 1,3 elimination or 1n elimination. So you don't have 1,3 or 1n elimination in your syllabus. You just have beta elimination. Okay, you just have beta elimination in your syllabus. So what causes beta elimination? You have first is KOH alcoholic. See, two things are there. If you have KOH aqueous here, then you will have a substitution reaction where bromine will be replaced by OH. But when you have KOH alcoholic, then it will cause dehydrohalogenation. That means bromine will leave from this side, this is alpha, and from the beta position hydrogen will leave. But that alkene will be formed which is highly substituted alkene, right? So this will be the correct answer here, right? Okay. For example, this E1, E2, so you can leave, right? Because that is actually, E1, E2 is actually, chalo, I'll give you a brief about that because it is not that much in CBSE, so they don't ask you this much. They ask you SN1, SN2, they don't ask E1, E2, right? But still I'll give you a little bit brief of that because we are doing important things, so I'll not confuse you with this one. But just remember one thing, just like in SN1, in E1 you have formation of carbocation, right? So in E1 also you have firstly the formation of carbocation, right? Firstly leaving group will leave, you will have the formation of carbocation. Then rearrangement of carbocation if possible will take place. Then you will have the elimination of hydrogen from the beta position. And that alkene will be formed which is more substituted. So this alkene has more substitution. This alkene has less substitution. So this alkene is formed. More alkyl substituted is the ZZF alkene which is formed. ZZF alkene, more stable alkene is formed. That is more alkyl substituted alkene is formed here. Right? Okay. Then in another case what we have, this is carbocation, again leaving group will leave. You will have the formation of a carbocation. As I told you, in E1 kind of mechanism you will have the rearrangement and then you will have the formation of a like a carbocation that you will have, that is this one, that is 3 degree. Then from the beta position elimination will take place. Elimination will take place from this hydrogen because this will give you more alkylated, right? Okay? So you don't have to remember this one, just remember this thing that E1 will give you carbocation, but in E2, just like in SN2, directly product will be formed, right? So you will have strong bases take place in presence of strong base such as alcoholic OH. So the reaction that we did, alcoholic OH, that was E2 mechanism, that was not E1, that was E2 mechanism. Okay, so that is very important. They can ask you this, that alcoholic OH, which is a very famous reaction, very important elimination reaction that you have, that is a E2 mechanism, right? That's it. You just need to know that that's a E2 mechanism where directly what you have, leaving group will leave and directly from the beta position hydrogen will leave. Now this is more alkylated, so this will not be chosen, this will be chosen. So A will give you the major product because that is your ZZF product, which is more alkyl substituted product. Okay, so that's it. You just need to know this much about elimination reactions, right? Now if you see this thing here, predict the major product for the following elimination reaction. So now they are asking you to predict the major product. See, you have Cl, you have iodine. Now tell me which one is a better leaving group. Iodine is a better leaving group. So iodine will leave from this side. This is alpha, this is beta. So you'll have the formation of double bond here, and hence this thing will be formed. So B is the major product. The one which is a better leaving group will leave. Right? So B is the major product here. Then alcoholic KOH. Very important question. Directly they can ask you these kind of questions. Alcoholic KOH, you have elimination. This I think we have done this already. Okay, we have already done this one. Okay. Chalo. Now let us take some break. Now from SN1 and SN2 I told you the difference of SN1 SN2. Short questions you will see from SN1 SN2 or elimination. Elimination is a topic where alcoholic KOH is an important reagent that you must remember, right? That how elimination works, and it will always give you set-zev product. You don't need to remember this will E1, E2. SN1, SN2 is important, and elimination alcoholic KOH is important for you. Okay? That much you should remember. Yes. Now I'll give you, yes. Now I'll give you break, right? And let's take 5 minutes break. After that, we'll do quickly some very important naming reactions, some very important reagent based questions. Okay, I'll also change my mic so that it is easy for me to teach you without holding the mic. So I'll give you just 5 minutes. I'll be back in 5 minutes, right? Okay, chalo, I'll be back in 5 minutes, right? So yes. Okay, so yes, everybody. Yes. So in another 1 hour, we are going to complete this session. So let's see some of the very important naming reactions and reagents. Like, okay, some of the very important naming reactions and reagents. Let's see that. Yes, everybody, ready. Everybody, do let me know. Let's finish this off. Yes, students. Let's finish this off, right? So important naming reactions, and from each chapter I'm going to teach you some of the important naming reactions and reagent, right? So if you see, first are some chlorinating reagents that you have, like chlorinating reagents that will replace OH with Cl, whether it's alcohol or it's ester or it's carboxylic acid. They will replace OH or OR with Cl, forming acid chloride or acyl chloride, right? Then you have two important reactions, that is firstly you have KMnO2 and AgNO2. AgNO2, we know that Ag forms a covalent bond with oxygen, right? And K forms a ionic bond with oxygen. Now that is the reason, this is the reason that here what will have, here it has an ionic bond, so that's why oxygen is free to actually form a compound. So the answer with KNO2 will be, if you have reaction of Rx with AgNO2 and the reaction of Rx with KNO2. With KNO2 you will have RONO. With AgNO2 you will have RNO2. Why? Because in case of AgNO2, Ag and oxygen are connected. So oxygen is not free for the attachment with carbon. But in ionic compound of KNO2, this oxygen here will be free. This oxygen will be free to connect with the carbon. So that's why you will have RONO in case of KNO2. Similarly, you will have with Ag, you will have similar thing with AgCN and KCN. If you have Rx with AgCN, it will form RNC. With KCN, it will form RCN. Because with the ionic compound, this carbon is free to connect with the R. So it will be forming RGCN. With covalent bond, this C is not free to connect with the R. So that's why nitrogen is connected to the R. So that's why you have the formation of isocyanide and cyanide. Then you have halogen exchange reaction, that is Finkelstein and Schwarz reaction. In Finkelstein reaction, guys, what we have in Finkelstein reaction, directly you will have a alkyl chloride or alkyl bromide you will have. You will react it with NaI and acetone. You will have the formation of iodo-alkyl, right? That is alkyl iodine. And with Schwarz reaction, you will have the formation of inorganic fluorides like EGF. And when you react this Cl will be replaced or Br will be replaced by fluorine, right? Because fluorine and iodine are difficult to form. Then you have Borodine-Hunz-Diecker reaction, in which you have carboxylic acid salt. You react it with the Br2 and CCl4, right? And you will have the formation of alkyl bromide with the release of CO2, and AgBr will be settled here, right? Then some important reactions of diazonium chloride. Now basically how diazonium chloride is formed. It is formed from aniline when you react it with NaNO2 and HCl in presence of 0 to 5 degrees Celsius. You will have the formation of diazonium chloride. This diazonium chloride, when you react it with salt and HCl, then you will have Sandmeyer reaction, which will give you chlorobenzene or bromobenzene. When you react this with copper powder and HCl, it will give you Gettermann reaction, that will again give you the same products. But when you use salt, that is called Sandmeyer. When you use powder, that is called as Getterman reaction. Okay. Then with Ki and you warm it, you will have directly iodobenzene. If you have HbF4, let's see, not NaBF4, let's see HbF4. NaBF4 also you can have. Basically BF4 negative ion you need to have here, right? You will have the formation of fluorobenzene, that is called as Bals-Schiemann reaction, right? Okay. Then there are reaction like you have Wood's reaction, Wood fatigue and fatigue reaction. Wood means you will have alkyl halide, right, and you will add sodium, NaX will leave and you will have the formation of RR, that is symmetrical alkane will be formed. In Wood's fatigue you will have alkyl halide and aryl halide, and you will have aryl and alkyl connect to each other, right. In fatigue reaction you will have two aryl halide and you will have the formation of biphenyl here, right. Now let's talk about Grignard reagent, how it is formed. So when you have alkyl halide, you react it with Mg and ether, you will have the formation of Grignard reagent. And Grignard reagent with any proton source means any proton source, like water is a proton source, any acid which is able to give proton, it will always form alkene. So Grignard reagent directly form alkane with the same number of carbons with any proton source you have, right. Then what is Friedel-Crafts reaction? In Friedel-Crafts reaction, you have benzene or any other aromatic compound you have. Electrophile will be generated. Here it will form an electrophile, that is CH3 positive, because this is a Lewis acid. It will take this Cl from there, it will form a R positive alkyl halide, carbocation, that will attack here and have the formation of toluene, right. Then from alcohol, phenols and ethers, what are the important reactions that you have? Now one of the important reaction is, three important reactions I am directly telling you. This is the conversion of alcohol to alkene. Three ways we have. First is acidic hydration. In acidic hydration you have rearrangement, attach of OH negative. That means you will form firstly carbocation, then if possible rearrangement will take place, then OH negative will be attached. Sorry, this is actually, I'm so sorry, this is actually the formation of alcohol from alkenes. Okay. So in case of acidic hydration, you will have carbocation, then rearrangement, then OH negative will attach. In case of hydroboration, directly anti-Markovnikov rule, that means negative part 2, more number of hydrogens will be attached. In case of oxymercuration, demercuration, you will have Markovnikov, that means negative part 2, less number of hydrogens directly. Negative part 2, less number of hydrogens directly. That is the major difference in acidic hydration, hydroboration, oxidation and oxymercuration, demercuration. Then guys, we have preparation of phenols. Out of this I will tell you what are the important reactions here. One of the important reaction is Dow's process, right. Then cumene process is quite important. Then you have, rest of it is not so important. This diazonium salt is important, okay. You must go through all of them, but I will teach you these three important reactions that are important for you. Otherwise, so every reaction is important, right. But as we are talking about only some important reactions, so we'll talk about firstly Dow's process, in which firstly you will have chlorobenzene under very drastic condition, very high temperature, high pressure, it is converted to phenol, right. Very high temperature and pressure we are using, and here benzene is formed as an intermediate. Then cumene process means you will have cumene, that is called isopropyl benzene. You will add O2 and H positive hydration. From here you will have the formation of phenol plus acetone. that will be formed here. That is another important reaction. Then from the diazonium chloride, you will have firstly aniline to diazonium chloride. Now benzene diazonium chloride is only stable between 0 to 5 degrees Celsius. If you warm it directly, you will have the formation of phenol here. That means this N2Cl is converted to phenol, right? Okay. Now this process is quite important. Dow's process is important for you. Okay? So right now though we are not focusing on the mechanisms, but I'll just give you this in the PPTs, right? Because for mechanism I'll take a separate session, because in this way though we can't complete the mechanism like that. But this I'll give you in the PPT. This you should remember that here benzene is formed as an intermediate. Okay. Now in subjective exams definitely mechanisms are very important. Dow's process code. I'll take a specific session on all the mechanism, important mechanism. I'll take a different session on that, right? Okay. Now let's talk about Lucas reagent. Lucas reagent is when you have anhydrous ZnCl2 and HCl. Now 3 degree turbidity is formed fastest. Turbidity is formed fastest, right? Immediately, you can say immediately, right? And 2 degree it is formed after 5 minutes, and 1 degree it is formed after 30 minutes, and that too after heating. So 3 degrees fastest, then 2 degree, then 1 degree for Lucas reagent, and this is the distinguished test of alcohol. Then another important reaction is Williamson synthesis reaction, in which you have RONA alkoxide and alkyl halide, which will form ether. That is Williamson synthesis ether reaction. Formation of ether is there. Now main thing is this should be alkyl halide should be primary. Only then this reaction will take place, otherwise this reaction will not take place, right? So this alkyl halide has to be primary, right? I'll just beta, as we are not talking about the mechanisms here, so I'll just delete all the mechanisms that we have. Okay? Chalo. Now let's talk about Kohl's electrolysis, Kohl's reaction. So in Kohl's reaction, you have from the formation on addition of NuH, you have firstly phenoxide ion. Now on adding CO2 and H positive, you have the formation of salicylic acid from Kohl's electrolysis. But in Riemer-Tiemer reaction, you have phenol. In this you add chloroform and aqueous NuH, and you have the formation of salicylic aldehyde, right? In Kohl's reaction, you have salicylic acid, and in Riemer-Tiemer, you have salicylic aldehyde. In Riemer-Tiemer, if you use CCl4, you will have salicylic acid. Okay? If you use this one, you can have salicylic acid there. Now, next is Kirchhoff reaction, right? Now, this is a reaction of the formation of, this is important, this you must have studied in class 11th as well. So, I will show you. Firstly, what you have to do is you have to break a pi bond, make a carbocation. On that carbocation, add H positive, OH negative, and this is H you will add here, right? One time, the one which is a stable carbon, like for example, this I will not talk about, I will rather talk about this one, right? Now here, which carbocation you will choose? I'll choose this carbocation here because it is attached to one CH3. I'll make one CH2, hydrogen is connected to this one. Then I will convert this into an alcohol. So this will be OH, this will be double bond, this is CH2. Now, once you have added H positive here and OH negative here, right? Water you have added. Now, if you see, you have the formation of enol here. You have the formation of enol here. Now, this enol will be tautomerized to give you CH3. This is C. Now, see one thing. This is 1, this is 2, this is 3. Double bond is shifted from this position to this position. So, you will have a double bond O. Hydrogen is shifted to this position, this is CH3, and that's how you have the formation of ketones or aldehydes from here, right? Okay, right? Beta, echo is there. Echo is there, is it? Is there any kind of echo? ठीक है? If we promise something now, I thought I'll start the class at 5 and it will end by 11 p.m. Right? But now what to do, because of technical issues, the class started at 8 p.m. Right? So I have to complete what I told you, right? Okay. I thought of completing mechanism also today, but I think there is no need of doing that. It will ऐसे ही waste. It will take. Wait a minute. Yes, wait a minute. Let me just cover this firstly. Then we'll talk about oxidation, right? Now, if you see this here, that is ether plus concentrated HI. So this is ether plus concentrated HI. Always remember, this particular part is quite important, that if R and R dash are primary, then it follows SN2. If one of them is tertiary, then it follows SN1. Any of them is tertiary. If it is SN1, that means carbocation more stable will be, I will be attached to more stable carbocation, and here I will be attached to less sterically hindered. Okay? Two things are there. This is quite important. I have just given you the conclusion here. R and R dash, if they are primary, it will follow SN2. That means you will form that alkyl halide which is less sterically hindered. But if you have one of them is tertiary, you will form that alkyl halide where carbocation is more stable. Okay, that thing is important. Now let's talk about oxidation. So guys, you have mild oxidizing agents, you have strong oxidizing agents, right? Let me see if we have oxidations anywhere else also. Wait a minute. Some actually, some part is not of CBSE, some part is of JEE. So I'm just checking. I don't want you to, suffer because of that. Wait a minute. I'll only teach you up to this one, right? That is there in CBSE. See, you just should remember one thing, that two things are there. One is mild oxidizing agent, then there are strong oxidizing agent. Mild oxidizing agents are like PCC, PDC, right? These are mild oxidizing agents. Strong oxidizing agents are like Jones reagent, that is CrO3 plus H2SO4 plus acetone, or you will have KMnO4, or you will have K2Cr2O7. These are strong oxidizing agents. Now what you will see, that if you have primary, secondary or tertiary alcohol, different things will be there. If you have a mild oxidizing agent or a strong oxidizing agent, okay, different things you will have here. Very important, this is a repeated question. This is 1 degree will always give you aldehyde. For strong, it will give you carboxylic acid. Okay? 2 degree will give you ketone, no matter it is mild or it is strong. 3 degree will not give you anything, whether it's mild or strong. It's mild or it's strong, right? Then if you talk about copper at 300 degrees Celsius, it will give you aldehyde with primary, it will give you ketone with secondary, it will give you alkene, which is very different, with tertiary, right, which was not happening in any of the case before. right? Okay, tell me, is that clear? Is that clear? Chalo, now let's talk about aldehyde, ketones and carboxyl here. So directly some questions are like repeated, right? I'll tell you here what are the things that, what are the reactions that are repeated. First is Rosenmund reduction, that is very important. You will have C double bond O Cn, and this is directly converted in presence of Lindlar's catalyst. This is directly converted to aldehyde, right? So this is Lindlar's catalyst, which is H2PD in presence of BSO4 that acts as a poison, right? And this will convert this COCl to CHO. That is Rosenmund reduction. Then in Getterman reaction, you have benzene. You reacted with COHCl and hydroClCl3. You will have the formation of benzaldehyde. Friedel-Crafts acylation, you will have RCOCl. You will have RC double bond O. That will attack here and it will give you like a ketone, right? Like for example, acetophenol, right? Then Itard reaction, you will have toluene, you will have chromyl chloride, which is actually red in color. It will react and it will directly give you benzaldehyde here, right? Side chain reaction in which you will have Cl2. Basically, you know how it will work. It will firstly give you this thing, CH, this is Cl, this is Cl. Then this Cl will be converted to OH on hydration. Then you will have the formation of double bond O here, and that's how you have the formation of benzaldehyde here. These are some specific reactions that are important. Now you have three categories of distinguished tests that are very important: Tollens, Felling, and Benedict. Tollens test is given by both aliphatic or aromatic aldehyde. Felling and Benedict is only given by aliphatic aldehydes. Only aliphatic aldehydes, right? Now, in all these cases, in case of Tollens test, you have silver mirror. When you react it with Ag silver ammonia solution, right? When you react it with Felling A and Felling B, that is copper sulfate and sodium potassium tartrate, right? It will give you red PPT of Cu2O. In Benedict solution, instead of sodium potassium tartrate, you have sodium potassium citrate. That will give you reddish PPT. Okay, that's how it will work, right? Chalo, let's see some other reactions. Let's see. Achha, one more important thing here in these distinguished tests, that is iodoform test. Okay? Iodoform test is given by this form CHI3, yellow color precipitates are formed here, and it is given by C double bond O CH3, or you should have CH3, COH and H. Either of these two will give you iodoform test, right? That is your iodoform test, right? Okay. Then you have two important reactions, Clemmensen and Wolff-Kishner reduction. In Clemmensen reduction also, this double bond O is converted to CH2. Here also double bond is converted to CH2. Here you have zinc amalgam HCl acidic condition. In Wolff-Kishner you have hydrazine and basic condition ethylene glycol KOH, right? So both of them are also directly asked to you. These are important naming reactions. Then Stefan reduction, you have RCN, that it reacts with this directly, when you reacted with SnCl to HCl, this directly give you RCHO, right everybody? Then let's talk about aldol condensation, that is very frequently asked to you. Okay, let me see. Wait a minute, this one will be here. Okay, I feel like now I should give you homework for the questions part, so we'll do that. Chalo, we'll do that. We will do that. Let's do that. I don't know if you have enough patience to do that or not. Chalo. Let's see. Okay, let's finish what we have decided. Right? Let's finish what we have decided. Right? Firstly, let's talk about aldol condensation. Here you should always have alpha hydrogen. Alpha hydrogen should always be present. These are all the reagents that can be there, but let's see how do you answer this. So in aldol condensation, what you will have here is, I'll talk about directly cross aldol condensation because aldol is same. Aldol is, you will have CH3, CHO. Because in cross aldol also it is going to show you aldol. Okay? So let's talk about that. Simple way is write the two parts CH3, CHO. In one part, open the alpha part, that is you will write it as CH2 and this is hydrogen. In other, you will open this part. This is connected to this alpha, this carbonyl is connected to this alpha, and here you have the formation of CH3C. This carbonyl that is connected, that will be changed to COH, right? I'll just rather write it here. This is CH3, this is COH, this H will remain. This is connected to this CH2, this is CHO. This is aldol. Now from alpha and beta position, you have the elimination of water. So you'll have CH3, CH, double bond CH, CHO. Okay? This is what we have here, and that is the answer. Now, ma'am, what else we can have? This also can show self aldol with itself. This is, I am telling you, in cross aldol you have self aldol also. So how do you write it? This is CH3, CH2, CHO. This is also CH3, CH2, CHO. Okay? Now what you do here? This is alpha, this is carbonyl, so I'll write it as C double bond OH. I'll connect these two, right? How do I write it? CH3, CH2, this is CHO. Then it is connected to that carbon, that is C, which is having OH and H, that is CH2CH3. Okay? Now from alpha and beta, you will have the elimination of water. That will give rise to CH3, CH, double bond CH, this is CHO, this is CH2, CH3, and that will be your answer of self-aldol of second thing, right? Ma'am, please take care of marathon going on. Beta, if I promise you, I will complete it. Whether it's 1 a.m., 2 a.m., okay, I'll do that. Okay, I know, but when we promise something, it's our duty to deliver that, right? That you will always see in Vedantu, right? So I will not be able to sleep also if I don't cover this today. I'll be like, yeah, there were some students, right? It doesn't matter to me how many students I have here. All matters is the students who are here, I know that they actually study, right? They are not here for chit chat and all that. Now see, I have cross aldol product. Now cross aldol product, I have two self aldol. This can react with itself, this can react with itself, giving you two self aldols. Now this can also show cross aldol. How? CH3, C, double bond OH. And here you will have alpha. CHO, this is CH, this is alpha, and this is CH3. Now this carbonyl is connected with alpha, this is connected to COH, so this will be CH3, COH, this is H, this is connected to CH, then it is connected to, this CH is connected to CHO and this CH is connected to CH3. Now from alpha and beta position, OH and H will leave. So you will have CH3, CH, double bond C, CH3, CHO. See how easily we are forming the products, right? Then what else last product can be? I can have CH3, I can have alpha of this one. So I can write it as CHO, CH2 and this is H. I can write carbonyl of this one. This is CH3, CH2, C double bond OH. Now I can just attack it here. Right now what you can have CH3, CH2, this is converted to OH, H and this is converted to CH2, CHO. Right? Now alpha and beta position you will eliminate water. This will be CH3, CH2, CH double bond CH, CHO. Alpha beta unsaturated aldehyde is formed. That is how you form cross-aldol and self-aldol products. Very important reaction, most important reaction. For Cannizzaro, directly what we will do, we'll convert one to the same number of, you have one carbon, you will have one carbon alcohol and you will have one carbon carboxylic salt will be formed. One will be alcohol, one will be carboxylic salt. Right? If you have cross Cannizzaro, the one which is less hindered will form the salt. So this is less hindered, this will form HCOONA. This is more hindered, this will form the same number of carbon alcohol. Okay? That is Cannizzaro reaction. Then there is Helvohard-Zielinski HVZ reaction, where in presence of H2 zinc, H2 and red phosphorus, alpha hydrogen is replaced by halogen and alpha monohalo acid is formed here. Direct reaction you need to remember here, that's it. Then guys, we have the formation of hemiacetal and acetal. Let's talk about that, right? Let's talk about that, everybody. Why you want me to sleep, guys? You're not enjoying the class, is it? Are you also tired? Because I am still in that energy, so don't worry. I'm a little bit tired, but it's okay. I know that if I leave it here now, then some of you who click, some of you will be watching this on the recorded version, and I don't want that some of you, then I see the comments. I just want that students who will watch this after 1 month or 2 months also, maybe before their pre-boards also, one day before the pre-board also, if you're watching this, then it's not like half between, ma'am, I got this video, but ma'am, in between you left the you ended the live, ma'am. Now what about other important topics, ma'am? Right? So I don't want to do that, right? So it's not easy to be a teacher. Huh? Your guilt will always kill you when you don't give your 100%. So hemiacetal and acetal, this is also an important example. So here just remember that from an aldehyde, right, by adding ROH 2 times, you will have the formation of acetal where 2 OR and 1 R and 1 H is there. Hemiacetal is where 1 OH, 1 OR and 1 R and 1 H is there. From ketone, you will have hemiketal and you will have the formation of ketal, right? Then cyclic ketal can also be formed from ethylene glycol with ketone, where water will be eliminated and this carbon is connected to this oxygen and this oxygen, and cyclic ketal is formed. This is also an important reaction, right? Now another reaction from aldehyde, ketones and carboxylic acid is where whenever you have a carbonyl compound, when it reacts with ammonia derivative, it will always take out water and you will always have CR R dash double bond NH2Z. Not NH2Z, my bad, it will be NZ. Because water will be eliminated here, you will always have the formation of this compound. Now this Z can be so many things. It can be hydrogen, R, OH, NH2, NH benzene, NH24 nitrobenzene, or it can be semi-carbazide as well, right? So R can be, Z can be so many things. Based on that, you will put the, for example, Z is OH, so you will put OH here. For example, Z is uh, H, so you will put H here, right? So Z can be anything. You will just have to put the value of Z, and accordingly you will have the formation of these things. This is a very, very important chart for your chemistry exam, board exam. This is a very important chart, right? Now we are just left with two more chapters, guys, right? Let's see. From preparation also, I'll give you some important reactions only. We'll see. Gabriel phthalimide and Hoffman bromamide degradation are two important reactions that you have, right? So Gabriel phthalimide, you have phthalimide in which you add KOH, then RX, you will have the formation of only the primary. When you add KOH, here you will have K positive. Then you have R, then this will give you R. Then these two bonds will break. Here you will have H and H, that is primary amine is formed in case of Gabriel phthalimide reaction. In case of Hoffman bromamide degradation, see, reduction of amides can take place in two ways. If you're reducing it with the help of LiAlH4 or any reducing agent, it will give you RCH2NH2. But if you are having Hoffman bromamide, you are using Br2KOH, it will give you RNH2. Degradation means one carbon less amine is formed here, right? One carbon less amine is formed in this case, right? Okay. Then, okay, this is done. This is also done, right? Mendius reduction, so it is there only. We have it here only. Mendius reduction is RCN is directly converted to RNH2, right? Actually, it is not RNH2, it is converted to RCH2NH2. From cyanide, you have RCH2NH2 with the same number of carbons, right? Wait a minute. This also not needed here. Let's see this one. Yes, then you have, wait a minute, let me see if we have that we have not written here. Wait a minute. Then we will have to go through this one. Check. Okay, so let's talk about this one, right? Now guys, you have this particular, from where I'll talk about two important reactions. One is carbylamine reaction, which is very, very important. Then you have Hinsberg test, which is very, very important. So these two things are quite important for your exam, right? Hinsberg and carbylamine, right? So in carbylamine, always if you have primary amines, that will give this test and form RNC, that is isocyanide. Foul smell will be there, and in this case it is same as Reamer-Teamer. The reagents are same as Reamer-Teamer. Chloroform and alcoholic QH is formed, and electrophile is also same, that is carbene is formed, right? But this is only shown by primary amines. It is detection test of primary. Hinsberg reagent is also a detection test only. This is the Hinsberg reagent. For primary amine, you will have actually the formation of C6H5 SO2 NH2. NH2R. No, you will have NHR. Because what will happen when you react this with NH2R? One hydrogen and one Cl will be eliminated. You will have C6H5SO2 NHR. When you react this with NR2H, H and Cl will be eliminated. For 2 degree, you will have the formation of C6H5SO2 NR2. For 3 degree, you don't have any reaction because 3 degree will be NR3. There is no hydrogen which Cl can be eliminated. So this reaction is not possible only. So Hinsberg reagent will give 1 degree, it will give a reaction, and with 1 degree it will form alkali soluble. Soluble alkali. That means alkali soluble, here alkali insoluble. Can you tell me why alkali soluble and insoluble? In this case, it is alkali soluble because here hydrogen is there. Here in the product, you don't have hydrogen attached to nitrogen, so it is alkali insoluble. That is the important test. That with 1 degree it will form alkali soluble, with 2 degree it will form alkali insoluble, with 3 degree it will not react only. Right? Now guys, we're talking about elimination reactions. So these are some of the important reagents that I told you, that in alcoholic KOH, dehydrohalogenation takes place. ZF product is formed here, right? Dehydrating is also elimination reaction. In this case, what we do, these are the dehydrating agents that we have. In both the cases, you will have the formation of ZF alkene as the major product. Okay? Here, water will be eliminated, OH and H will be eliminated. Here, halogen and hydrogen will be eliminated. That is the difference, and the reagents are different. Right? Okay? So, in case of dehydration, especially if you talk about alcohol, if the temperature is 170 degree, temperature is high, what will happen? OH will leave and hydrogen will leave. From one compound only, one molecule you will have the elimination, you will have alkene. But if the temperature is low, then what will happen? You will have CH3, CH2OH. Here also you will have CH3, CH2OH. And you will have the elimination of water, and you will have the formation of ether here. Right? So if the temperature is low, 140, it will have the formation of ether, otherwise alkene will be formed. Right? Then another reagent is allylic bromination, in which when you have NBS, N-bromosuccinimide, or Br2H mu or Cl2H mu, okay? Only allylic means C double bond C, and this particular carbon is allylic carbon. This particular hydrogen will be replaced by the chlorine or bromine here. Right? Chlorine or bromine. Allylic carbon will have the substitution, or I'll just write here halogen. Right? Or benzylic carbon will have the, benzylic means this carbon. This carbon is benzylic, that will have the substitution. Okay? Allylic or benzylic substitution will take place in these reagents. Okay, that is very important in your NCERT. Direct question they have given based on this one, right? Now, the difference of LiAlH4 and NaBH4 is also very important. Remember that LiAlH4 will reduce everything. It will also reduce acid, amide, ester. It will reduce everything. But NaBH4 will not reduce RCOH. That means acid, amide, esters are not reduced by NaBH4. But RCOCl is reduced by NaBH4 also, LiLH4. This is also an important question that they can ask you, right? Okay. Then guys, we have electrophilic substitution reaction that you will see in every single chapter. All you need to do is which is the electrophile that you have, right? And always remember, if you have a group that has lone pair, that will give you ortho-para directing groups, ortho-para directing product. If you have a group which is attached to an electronegative element with a multiple bond, then it will give you meta-directing group. Just remember that, right? This will give you X positive as the electrophile. Nitrating mixture will give you NO positive. This RCl and anhydrous AlCl3 will give you R positive. RCuCl and AlCl3 will give you RCO positive. Then concentrated H2SO4 or oleum will give you SO3 as the electrophile, right? Okay. Now let's see 2-3 important reactions here that we have. First thing is, if you have phenol and you have the formation, wait a minute. If you have phenol and you react this with, wait a minute. If you have phenol and you have bromine in CS2, ortho-para product will be formed differently. If you have bromine water, white precipitates of this product will be formed. That means ortho-para product is formed. There is no different product, ortho product different, para different. 3 ortho-para substitution in the same product is formed. But in case of aniline, you can never have mono-substituted product. For mono-substituted product, you need to do acetylation. Acetylation means what you will have, you will substitute this hydrogen with COCH3 and then you react Br, then only para product is formed. Right? Then you do hydrolysis, directly you will have only para product. Only from acetylation you can form only para product, otherwise it's not possible. Then guys, if you talk about nitration, it's a very, very important reaction that has been asked, and this, I feel this is from amines, either Hinsberg reagent or carbylamine or Hoffman bromamide or basis or no, yes, questions on basicity also they can ask you. Then this one, that in nitration, what exactly happens? In nitration, you have concentrated HNO3. You have H2SO4, which is very acidic. That is why this forms anilinium ion. This base will accept as proton from an acid, it will form anilinium ion, which is meta-directing. That is why aniline is ortho-para directing. In reality, meta product should not be formed. But it is forming meta product because anilinium ion is formed, and this is a very important question. Why in nitration of aniline you have meta product? Because of this thing, right? Okay. Then you have what we actually do here. We do acetylation. We replace hydrogen with COCH3. Now, because of this COCH3, that is already, because if what will happen here, it will be involved. These lone pairs are not free for the acceptance of proton. See, here what was happening? These lone pairs were accepting the proton and forming anilinium ion. Now, because of acetylation, these lone pairs are not accepting the H positive. That is the reason no anilinium ion is formed. That is the reason only para product is formed here. No meta product is formed in this case. Okay, beta, tell me if that thing is clear to all of you or not. Right? Now, wait a minute. Wait a minute. Because we have already done so many questions now. So I'll be directly giving you, wait a minute. This too we have done. Okay, this also we have done. This also we have done azodite test. Not important here. Chalo. Because some things are actually, I think, extra added here. Right? Now those questions I'll give you for homework for organic chemistry. I'll just show you some last two important topics and we'll see some of the questions are like we will see and some of the questions I'll give you for homework, right? So now from biomolecules, what you need to do, right? From biomolecules, guys, we have like 2-3 very important topics, right? Directly I'm telling you. First is structure of carbohydrates. Okay? Draw it yourself once, twice, thrice, do it again and again and again. You should know this, right? You should know what is the structure of glucose, right? Alpha glucose, beta D glucose, alpha D fructose, beta D fructose, that should be on your tips, right? How a six-membered ring is formed here. The difference between alpha and beta is that on the carbon 1 the configuration is opposite. That is the difference in alpha and beta. Here on the carbon 1 the configuration on this particular carbon is opposite. That is the difference in alpha and beta, right? So these structures should be on your tips, right? Then if you talk about sucrose, now these linkages should be on your tips, right? That when you talk about disaccharides that are formed from the combination, the glycosidic linkages of two monosaccharides, how they are formed. So sucrose is formed, that is a non-reducing sugar, that is formed by alpha D glucose and that is formed by C1 of alpha D and C2 of beta D fructose, right? Then a linkage between C1 of galactose and C4 of glucose, that is there in lactose. In case of maltose, C1 of glucose and C4 of alpha D and other glucose units. Directly they can ask you question, they can ask you to draw sucrose, sucrose, maltose, lactose, they can directly ask you this as well. Structure of glucose, they can ask you. This is least that you should like must to do things from your carbohydrates. Otherwise, yes, the reactions of glucose are also very important, but this is the most important topic from there, that you should definitely know the glycosidic linkages, the structures of glucose, fructose, right? All these things. For example, in CBSE 2023, they have asked a question that is maltose is made up of alpha D glucose and beta D, glucose and fructose, D fructose. So it is formed from alpha D glucose. How it is formed? They can also ask you the linkage. It is formed from C1 and C4 linkage of alpha D glucose. You should also know the linkages here. Maybe in 2026 they will ask you linkages, right? In MCQ form they can ask you. They can also ask you to draw the structure because it's a subjective exam. So they can also ask you to draw the structure, right? Then glucose gets oxidized. This is the based on reaction based question, right? This is based on reaction based. Acha, then you have DNA RNA. Now in DNA RNA, the like a very important question is that you should know that in DNA you have adenine, guanine, cytidine and thymine. You have A, G, C, T. Here you have A, G, C, U. Here you have T and here you have U. In RNA you have U. In RNA you have U. Okay? Acha, here the pairs are between A and T, G and C. A and T, A and U, G and C. Okay, right? These are the pairs of nitrogen bases that you have. So see, the base which is present, CBSE 2021, simple thing, they have asked one question. Base which is present in DNA but not in RNA, that is now wait a minute, cytosine, guanine, DNA but not in RNA, that is thymine. Thymine is not present in RNA because uracil is present in RNA, right? Okay, that you should know. What are the nitrogen bases, right, that are present in DNA, RNA. Then about the protein, a very important topic is primary, secondary, tertiary and quaternary structures, right? Now primary, it's just like the complexity will keep on increasing as the structure increases. For example, primary structure, see, protein are made up of amino acids. So amino acid linkages are primary structure. When you have like how they are connected, are they in a alpha helix structure, are they beta pleated structure, that defines the secondary structure. Now when these different alpha helix are connected with each other, right, into some other structure, right, that is tertiary, more complexity, like how this structure is between a tube, right, then how this structure is again, now this how these different structures are, like, see, it's like the zoom out version, zoom out you are doing. First you are seeing amino acid linkage, then you are saying that they are also forming a like good like alpha helix like a spiral, or a beta plated like a wave, like. Now when we are saying that whether it's alpha helix or beta plated, how it is there in a tube, how it is connected, right? Then when you have various tertiary structure connected with each other, see, two tertiary structure connected with each other will give you quaternary structure. That means the complexity is going to increase as you go from primary to quaternary. Now this is a very important question that says, complete the following analogy: curdling of milk and U helix, right? What is A and what is B? This you have to do. So curdling of milk is basically denaturation of protein, and alpha helix is a secondary structure like beta plated, alpha helix, these are secondary structures. So answer will be D is the correct answer here, right? Okay, cuddling I am saying curdling of milk, right? My brain. Okay, acha. Now before doing that, let me see if there are some important questions that I should do myself or I should give you for homework, right? Chalo, I'll see some of the questions that I can give you for homework and some I'll do myself, right? So how do the following conversion works, right? So they are asking you how do this conversion work. So we know that this conversion of our COCl to our CHO, it's not COOCl, it's COCl. This will be using Lindlar's catalyst, that is Rosenmund reduction. So answer will be A is the correct answer here, right? Similarly, you can see give IUPAC name to nahi, ठीक है? This is, I don't know why some these kind of questions are there, but yeah, that is not correct. Okay. So if you see this, the correct increasing order of basic strength. Acha. Now basic strength also, I have not taught you this in today's class, but this is actually from GOC, but that also can be asked in 12th class. Basic strength is directly proportional to electron donating and inversely to electron withdrawing groups, right? So electron donating is this group, so it will have maximum basic strength. Then you will have first, then second will have least because it is electron withdrawing minus electron withdrawing group. So answer will be D is the correct answer here, right? Then guys, you have this is the question that I was actually looking for. Okay, let's see this one. Right, let's see this CBSE 2019 question here, right? It says that given equation of the following base, this was the question that I have added now. Based on that, so I have given you extra questions, but this is the question that I want to teach you for CBSE specific. So given equation of the following reaction, phenol is treated with concentrated HNO3, propene is treated with B2 followed by this, sodium tert-butyl is treated with this. How will you distinguish between this and this? Arrange the following in increasing order of acidity. So all are these questions that they have asked you. Let's see, phenol is treated with concentrated HNO3. Phenol with concentrated HNO3 will give you 2. With dilute HNO3 will give you ortho and para different products. With concentrated it will give you picric acid. Then propene undergoes hydroboration oxidation. That will follow anti-Markovnikov addition. That means it is going to, negative part is going to attach to more number of hydrogens. So you will have OH here and H here. Right, so that's why you will have propane 1-ol as the correct answer. Then third is sodium tert-butyl is treated with CH3Cl. So sodium tert-butyl means CH3Cl is treated with sodium tert-butyl. Okay, is it Williamson synthesis reaction? Yes. So it will give you ether, that is this one. Why this reaction has worked? Because the alkyl halide is primary, right? That's why this reaction is actually taking place. So we have done. Then they are saying that was A. How will you distinguish between butane? It's not butane, it's butane. How will you distinguish between butane 1-ol and butane? Butane is the same. Butane, beta. We are not distinguished between butane. It's butane. Butane 1-ol and 2-ol. See, it's primary and it's secondary, right? So we know that by Lucas test we can distinguish. Primary it will not give turbidity. Secondary it can. Butane 2 means this thing. 2-ol means this thing. Okay, so it is butane 2-ol means 2 degree. So Lucas reagent after 5 minutes it will give you the turbidity, right? Whereas butane 1-ol won't give any turbidity. This is based on Lucas test that I have just told you about, right? Then last part is based on acidity. Now acidity I have not taught you in today's class, but this is actually based on class 11th GOC, right? That you should know, right? But still, if you see this here, phenol, ethanol and water, this is based on hydrogen bonding. So we know that phenol, because it shows resonance to the maximum extent, then water, then ethanol has least. This is the acidic order, right? This you should remember as it is, right? Okay, this I have not taught you in today's lecture because I have only taught you some of the major important reactions, right? So some part, right? This actually, if you see alcohol, phenol in detail, then you will study that, right? Then aromatic aldehydes and formaldehyde undergo Cannizzaro reaction. Assertion reasoning question, how they can ask you. Aromatic aldehyde and formaldehyde undergo Cannizzaro. Aromatic aldehyde and formaldehyde. See, Cannizzaro reaction will be shown by the one which do not have alpha hydrogens, right? Are almost as reactive as formaldehyde. See, both will show Cannizzaro reaction. Aromatic aldehyde and formaldehyde do not contain alpha hydrogen. Thus, they undergo Cannizzaro reaction. Formaldehyde is more reactive than the aromatic aldehyde, right? Because of less steric hindrance, formaldehyde is more reactive. So answer will be, statement A is correct, but reason is not correct, right? Formaldehyde is more reactive. Then next question can be, both symmetrical and asymmetrical ethers can be prepared by Williamson synthesis reaction. Yes. Williamson is an example of nucleophilic substitution. Yes, it follows SN2 mechanism, right? So here answer will be, assertion and reason both are correct, but reason is not the correct explanation. They are not related to each other. Why it is giving symmetrical and symmetrical? Because it is substitution reaction. No, there is no reason. right? So both are true, but they are not reason for each other. So answer will be B is the correct answer, right? Okay. Then aldol condensation can be catalyzed by both acid and bases. Beta hydroxyaldehyde or ketone readily undergo acid catalyzed dehydration. Beta hydroxy, yes, they readily undergoes acid catalyzed dehydration. So answer will be both carbanion formed in presence of base and enol formed in presence of an acid act as nucleophile and hence react with this one. You should know the mechanism, then only you will be able to know that. But just remember that yes, it is shown by both, right? So aldol condensation can be given in presence of acid and bases both. Okay, if you have not gone through mechanism, you should know that this actually happens in both the cases. Beta hydroxy, now these kind of questions that are this much detailed, for that you have to go through mechanism as well, right? Beta hydroxyaldehyde or ketone readily undergo acid catalyzed hydration. That's how we were eliminating water from the from the aldol, and we were forming alpha beta unsaturated aldehyde, right? So this is also true, but they are not explaining each other, right? Okay, tell me, and that's how our target is done, right? Okay, so for organic chemistry I have focused, guys. There were two things that I could have focused, because you know, in a marathon I it's very selective thing that I have chosen. So I could have focused on just the questions for, or see, for physical chemistry I have focused on more questions, right? Why? Because I know that with just knowing the formula you won't be able to understand anything. But for organic chemistry, I have focused less on questions and more on like telling you about the reactions. Because if you're here, right, to know only the important topics, then it's my duty not to confuse you with, it's my duty to tell you that from physical chemistry you should know the application of formulas. For that you will should know the questions. But for organic chemistry, if you're doing a revision, then you go through not the questions, go through the naming reactions, do the revision of that, right? Because eventually questions will be same as the theory part in organic chemistry, right? Okay, but SN1, SN2 is something where you needed some questions. So that's why I have given you a lot of questions in SN1, SN2. So I have tried my best to take this in such a manner so that in 5 to 6 hours we are able to, you know, complete this, right? And we are able to do that. So I am very, very happy about it, right? Yes, everybody. Yes. Yes, the class is over. The class is over, guys. The class I have completed. Don't worry. Right? I have completed it. Right? That's what I told you, na? Chalo. Now, one thing to tell you, right? That guys, the test series for JEE is at off. So if you're preparing for JEE as well, right? What you need is a good revision. So that's why, guys, this test series that is just now available at just 999, that is available to you. The link is in the description. Go and check that out. And also MVSAT scholarship program is extended to 2nd of November. Go and check that out, and you can see the link in the description box, right? Okay. Yes, students. Chalo. Okay. Now my now to my head is like, my brain is not braining at this point, right? So I'll see you all in the next class, and I'll start very, very important thing we are going to start this week, right? Shreya sir will inform you about it soon. I think tomorrow he's going to inform you about the thing that we are going to start, right? So everybody, wait for that. For JEE aspirants especially, we are going to start that, right? Okay, chalo. Okay then guys, bye bye, and I'll see you all in the next class. Bye bye, take care, and do write something in the comment section. I wait for that, right? I'm here till 1 p.m., 1 a.m. So do something, write something in the chat box, right? Okay, bye bye, take care, bye bye.